Hello there and welcome to Science for Sleep, where curiosity gets comfortable and big questions drift gently through the mind like soft clouds passing across a quiet night sky. Tonight, we're setting our thoughts a little farther from home than usual, not just beyond the horizon, but beyond the very world beneath your feet, toward a small, rust-coloured planet that has been watching Earth in silence for billions of years. Before we wander too far from our familiar skies, let me ask you something simple and grounding. Where are you listening from right now? Are you tucked into bed, leaning back in a chair, or maybe letting this play softly in the background as the day finally loosens its grip? And what time is it in your little corner of the world as these words find you? It's always a gentle thought to imagine listeners scattered across the globe, each one wrapped in their own moment of night or morning, all meeting here in this shared pocket of calm. If this slow, curious journey feels soothing, or if it helps you unwind even a little, you're always welcome to like the video or subscribe, so this quiet space can find its way to someone else who might need a peaceful pause, no rush, no pressure, just a soft invitation, like leaving a light on in the window. Now let's begin our story, not with rockets or countdowns, but with a feeling humans have carried for as long as we've looked up at the sky. Mars has always been there, a small reddish dot wandering among the stars, sometimes bright, sometimes faint, but never truly gone. Long before telescopes and space agencies, people noticed it and wondered. Ancient cultures named it after gods of war, fire and movement, giving it personality shaped by imagination and myth. To them it wasn't just a planet, it was a symbol, a traveller, a distant companion in the vast dark. Even now, with all our data and diagrams, something about Mars still feels personal, as if it's quietly inviting us to come closer. In the modern world, we often talk about going to Mars in practical terms. Rockets, habitats, fuel, schedules, budgets. But beneath all of that, there's a quieter question that doesn't always get spoken out loud. What would it really mean to leave Earth behind, not just for a visit, but for good? What does it feel like, deep down, to step onto a world where turning around and coming home might not be part of the plan? To understand why the journey to Mars is often described as a one-way trip, we have to start with something simple and strangely comforting: distance. On a map, Earth and Mars look like neighbours. Two small circles and a neat line around the Sun. It feels manageable, like crossing a long ocean, or flying to the other side of the planet. But space doesn't work the way our everyday sense of travel does. There are no straight roads out there, no constant speeds, no quick detours. Everything moves, and everything is always in motion, including the worlds themselves. Earth and Mars don't sit still. They chase each other around the Sun on their own looping paths, sometimes closer, sometimes farther apart. At their nearest, they're still about 56 million kilometres apart. At their farthest, that distance can stretch to more than 400 million kilometres. To put that into something more familiar, imagine circling the entire Earth over 1,000 times. That's the kind of gap we're talking about, and it's mostly empty, silent, and filled with things that are very unfriendly to human bodies. When a spacecraft leaves Earth for Mars, it doesn't point itself straight at the red planet and go. Instead, it follows a long, curved path, carefully calculated so that both the ship and Mars arrive at the same place at the same time months later. This kind of journey, called a transfer orbit, is all about patience and precision. You don't rush it. You let gravity and motion carry you along, like drifting down a very wide, very quiet river. That river takes time, usually about 6 to 9 months, depending on the exact path and the positions of the planets. For half a year or more, the crew would be sealed inside a metal shell, floating through a space where there's no air, no warmth, no protection, except what they brought with them from Earth. Outside, the Sun is both a distant friend and a quiet threat, providing light and energy, but also sending out invisible radiation that can pass through metal and into living tissue. Here on Earth, we don't think much about radiation. Our planet is wrapped in a thick atmosphere and a powerful magnetic field that quietly deflects most of the dangerous particles streaming in from space. It's like living under a giant invisible umbrella. In deep space, that umbrella is gone. Every day of the journey adds a little more exposure, a little more risk. The body keeps going, of course. The heart still beats, the lungs still breathe, the mind still dreams. But on the cellular level, things are being nudged and changed in ways that don't always show up right away. This is one of the reasons returning from Mars isn't as simple as packing up and heading back. The journey itself takes a toll, and the longer you stay, the more that toll adds up. Muscles weaken in low gravity, bones slowly lose their density. The immune system shifts. Even vision can change as fluids move differently inside the body. None of these effects are instant, and many can be managed or slowed, but they remind us that the human body is very much designed for Earth. It grew up under one gravity, one atmosphere, one protective sky. Mars offers none of those in the same way. Now, let's imagine the moment of arrival. After months of travel, Mars grows from a bright dot into a real world, filling the windows with shades of red, brown, and gold. There are no oceans glinting in the light, no clouds drifting lazily by. The sky is thin and pale, tinted slightly pink by fine dust floating in the air. The land stretches out in wide, quiet plains, broken by ancient volcanoes and deep, dry canyons that hint at a wetter, warmer past. Stepping onto Mars wouldn't feel like stepping onto another version of Earth. It would feel like arriving on a world that's almost a planet, but not quite. The gravity is only about a third of what you're used to. Every movement would feel lighter, slower, a little floaty. At first, that might seem fun, like walking in a long, gentle dream. But over time, that reduced pull would begin to change the body in subtle ways, encouraging muscles and bones to let go of their strength, because they no longer need to work as hard. And then there's the air, or rather, the lack of it. Mars's atmosphere is thin, about 1% as dense as the Earth's. It's mostly carbon dioxide with hardly any oxygen at all. You can't breathe it. You can't stand in it unprotected. Without a suit or a habitat, you'd lose consciousness in seconds. Every moment of life on Mars would depend on carefully maintained systems, machines that create air, manage pressure, and keep temperatures within a narrow, livable range. Those systems don't just need to work once. They need to work every day for years without fail. On Earth, if something breaks, you call a technician, order a part, or drive to a store. On Mars, there is no store. There is no quick delivery. Everything you might need has to be planned, packed, and sent years in advance. Even then, something unexpected will always happen, because complex systems in harsh environments always find new and creative ways to surprise us. This is where the idea of a one-way journey begins to take shape, not as a dramatic statement, but as a practical reality. To come back from Mars, you don't just need a ship, you need fuel, a lot of it. More than you could realistically carry all the way from Earth, because every kilogram of extra mass makes the launch harder, more expensive, and more complicated. One solution scientists explore is making fuel on Mars itself, using local resources like carbon dioxide from the atmosphere and water ice from the soil. In theory, a small factory could turn those into rocket fuel, waiting patiently for the crew to arrive and use it for the return trip. In theory, it's elegant. In practice, it means trusting your entire journey home to a machine that's been running unattended on another planet for years, in dust storms, cold nights, and conditions we've only experienced through robotic explorers. If it fails, there's no backup, no tow truck, no rescue mission that can arrive in a few days or even a few months. The window for launching back to Earth only opens every couple of years, when the planets line up just right again. Miss it, and you're waiting a long, long time. So when people talk about early Mars missions as one-way trips, they don't always mean that no one wants to come back. They mean that realistically the safest and most reliable plan may be to build a life there instead of planning an exit. That idea changes the whole tone of the journey. This wouldn't be like visiting a research station in Antarctica or spending a few months on a space station. It would be more like the great migrations of the past, when people boarded ships knowing they might never see their homeland again. They carried seeds, tools, memories, and hopes, not return tickets. Imagine standing on the surface of Mars and looking up at the sky. Earth would be there somewhere, a bright blue-white star among many. You wouldn't see continents or clouds. You wouldn't see oceans. Just a point of light that holds everything you've ever known. Every city, every forest, every person you've ever met, all tucked into that tiny glow. It's a quiet, humbling thought, and one that might visit often in the stillness of a Martian evening. But the story doesn't stop with distance and machines. There's also the human mind to consider, which carries its own kind of gravity. Life on Earth is full of small, comforting signals. The sound of wind in trees, the smell of rain, the feeling of grass under your feet or warm pavement under the sun. These are things we barely notice, but they anchor us in a world that feels alive. On Mars, the environment would be mostly silent. No birds, no flowing water, no rustling leaves, just the soft hum of air systems and the crunch of boots on dust. Over time, that kind of quiet can feel very big. Communication with Earth wouldn't be instant. Messages would take anywhere from a few minutes to over 20 minutes to travel one way, depending on where the planets are in their orbits. A conversation would stretch across nearly an hour. You couldn't call someone in a moment of excitement or worry and hear their voice right away. Every exchange would feel like sending a letter across space and waiting for the reply. This delay doesn't sound like much, but emotionally it changes things. It creates a gentle, persistent distance, even from the people who care about you most. Over years, that distance becomes part of daily life, a background hum, like the sound of the air systems themselves. And yet, people still want to go. There's something deeply human about stepping toward the unknown, even when the path doesn't promise an easy return. Mars represents more than a destination. It represents a question. What kind of species are we? Are we content to stay where we began? Or do we feel a pull to carry our stories, our science, and our quiet moments of wonder to new worlds? As you rest there, listening, breathing slowly, let that question sit gently in your thoughts, without needing an answer right away. This journey isn't just about rockets and red dust. It's about the long, patient relationship between curiosity and courage, between comfort and change. Somewhere between the first time a human looked up at the night sky and the moment you press play on this video, Mars has been quietly collecting attention. Not loudly, not with the brilliance of Venus or the steady presence of the moon, but with a softer, more persistent kind of pull. It shows up as a small red wanderer among the stars, never quite staying in one place, always drifting, as if it has its own plans that don't entirely align with the rest of the sky. Long before anyone knew it was a planet, long before the idea of space travel even existed, people noticed that this particular point of light behaved differently. Most stars seemed fixed, pinned to the sky like tiny holes in a dark curtain. Mars, along with a handful of others, moved. Night after night it slid slowly across the backdrop of stars, tracing a path that felt deliberate, almost purposeful. Ancient astronomers called these moving lights wanderers, which in Greek became planets, and from the very beginning, that sense of wandering gave Mars a personality. In many early cultures, the red colour was impossible to ignore. Against the deep blue and black of the night, it stood out, faint but distinct, like an ember that refused to go out. The Babylonians associated it with Nergal, a god of war and destruction. The Romans named it after their own god of war, Mars, and that name has stuck with us ever since. To them, the red glow suggested blood, fire, conflict, and power. It wasn't just a light in the sky. It was a symbol, a presence that felt connected to the struggles and passions of human life down on the ground. But it wasn't all about war and danger. In other traditions, Mars took on different meanings. In ancient China, it was known as the fire star and was associated with change and imbalance, a kind of celestial messenger that hinted something in the world below might soon shift. In some Native American stories, it was seen as a traveller, a being on a long journey of its own, moving across the sky with quiet determination. No matter the culture, Mars rarely blended into the background. It invited interpretation, stories, and a kind of respectful curiosity. As centuries passed, that curiosity grew more focused. The invention of the telescope in the early 17th century didn't just change astronomy, it changed how humans related to the sky. Suddenly, the wandering red dot wasn't just a symbol anymore. It became a world, something with shape, size, and surface. Galileo Galilei turned his telescope toward Mars and saw it as a small disk, not a point of light. That simple observation carried a powerful implication. If Mars was a disk, like the Moon, then it might be a place, not just a light. A few decades later, other astronomers noticed that Mars seemed to have polar caps, bright white patches at its top and bottom that changed with the seasons. That detail was both thrilling and strangely familiar. On Earth, ice caps meant cold, water, and cycles of climate. If Mars had something similar, then maybe, just maybe, it wasn't entirely alien. Maybe it was a distant cousin, shaped by some of the same rules that shaped our own world. The more people looked, the more their imaginations filled in the gaps. Telescopes in the 18th and 19th centuries weren't powerful enough to show fine details clearly, so the surface of Mars appeared as a blurry mix of light and dark regions. Astronomers gave these areas names, often inspired by seas, continents, and landmarks back on Earth. There were Maria, or seas, even though no one had a proof they were filled with water. The language itself suggested a kind of quiet hope. Naming something after a sea implies waves, shores, and maybe even ships. Then came one of the most influential and misunderstood moments in Mars' long relationship with human imagination: the canals. In the late 1800s, an Italian astronomer named Giovanni Schiaparelli observed Mars during a particularly close approach to Earth. He sketched thin, dark lines crisscrossing the planet's surface and called them canali, which in Italian means channels. When this word was translated into English, it became canals, a term that carries a very different meaning. Channels can be natural, canals are built. Suddenly Mars wasn't just a distant world, it was potentially a world with engineers. This idea took on a life of its own, especially through the work of American astronomer Percival Lowell. He became convinced that these canals were part of a vast planet-wide irrigation system, built by an advanced Martian civilization to move water from the polar caps to the dry equatorial regions. He wrote books, gave lectures, and painted a picture of a dying world where intelligent beings were making a last grand effort to survive. The public loved it. Newspapers, novels, and conversations at dinner tables began to include Mars as more than a scientific curiosity. It became a setting for stories. Writers like H.G. Wells imagined Martians not as struggling survivors, but as powerful invaders, watching Earth the way humans watched Mars, planning their own journey across the void. His famous story about a Martian invasion wasn't really about aliens at all. It was about fear, colonialism, and what it feels like to be on the receiving end of a more advanced power. Mars once again became a mirror for human hopes and anxieties. Even as better telescopes revealed that the canals were likely optical illusions, tricks of light, and the human brain's tendency to connect patterns, the spell had already been cast. Mars was now firmly embedded in the cultural imagination as a world that might, in some way, resemble our own, or at least reflect something about us. As the 20th century unfolded, Mars took on a new role. It became a destination. The idea of rockets and space travel moved from fantasy to engineering problem. Scientists like Konstantin Tsiolkovsky and later Wernher von Braun began to sketch out what it would take to leave Earth's gravity and reach another planet. In their diagrams and calculations, Mars wasn't just a point of light anymore. It was a goal, a place you could, in principle, stand. When the space age truly began in the late 1950s and early 1960s, Mars quickly became one of its main characters. Early robotic missions flew past it, sending back grainy images that showed a world of craters, vast plains, and towering volcanoes. The surface looked dry, cold, and empty, but also grand in a quiet, ancient way. There were no cities, no canals, no visible signs of a life. Yet in some ways that made it even more compelling. It felt like a blank page, a place where a new chapter of exploration could be written. Then came the orbiters and landers, machines that didn't just glance at Mars but stayed, watched and touched. They rolled across its soil, analysed its rocks and dug into its past. They found dried riverbeds, mineral deposits that form in water, and hints that long ago Mars may have had lakes, maybe even oceans. The planet that once lived only in stories and sketches began to reveal a real history, one that included warmth, flowing water, and the possibility, however faint, that life might once have taken hold there. This discovery added a new layer to Mars' pull on the human mind. It wasn't just a world we could imagine life on. It was a world where life might actually have existed. That idea is powerful in a very quiet way. If life arose on Mars, even in a simple microbial form, it would suggest that life isn't a rare miracle confined to Earth. It might be something the universe does naturally given the right conditions. Mars, in that sense, becomes a kind of test case, a way of asking one of humanity's oldest questions in a scientific, grounded way. Are we alone? But beyond science, there's something else at work. Mars sits at a sweet spot in our cosmic neighbourhood. It's far enough to feel like a true other world, but close enough to feel reachable. We can't imagine going to a star, not yet. Even the nearest one is so distant that it stretches beyond our everyday sense of time and travel. Mars, on the other hand, is just a few months away, in terms of spacecraft. It's distant, but not impossibly so. That balance makes it a perfect target for both dreams and plans. There's also the way Mars resembles Earth, just enough to feel familiar. It has a day that's about the same length as ours. It has seasons. It has polar ice. It has mountains, valleys, and dust storms that can wrap around the entire planet. When we look at images from the surface, taken by rovers, we sometimes see landscapes that could almost be mistaken for deserts in the American Southwest or dry rocky regions on our own planet, if not for the colour of the sky. That almost is important. Mars is close enough to remind us of home, but different enough to remind us that it isn't. That tension between familiarity and strangeness is a powerful driver of imagination. It invites us to project ourselves into the scene. What would it feel like to walk there? To see that pale sky overhead? To watch a sunset that looks more blue than red because of how the thin atmosphere scatters light? These are small, sensory questions, but they open the door to much bigger ones. If we can imagine ourselves there, even in a quiet, casual way, then the idea of going there doesn't feel entirely impossible. It feels like a step, not a leap. There's also a deeper layer to this fascination, one that has less to do with Mars itself and more to do with us. Humans are a storytelling species. We don't just observe the world, we weave it into narratives. We look for beginnings, middles, and futures. Mars fits neatly into a very old story, the story of the frontier. For much of human history, there has always been a beyond the next hill, beyond the ocean, beyond the edge of the map, where artists once drew dragons and sea monsters. That unknown space was frightening, but it was also full of possibility. It promised new lands, new resources, and new chances to start again. Mars has, in many ways, become the modern version of that edge of the map. It's the place where our current world ends and something undefined begins. This idea doesn't always sit comfortably with everyone. Some people see it as a kind of escape, a way of avoiding the problems we face here on Earth by dreaming of somewhere else. Others see it as an extension of the same curiosity and resilience that carried humans across continents and oceans in the past. Mars, in this view, isn't a backup plan. It's a continuation of a very old habit, looking at the horizon and wondering what's on the other side. That habit shows up in subtle ways, even in how we talk about Mars. We don't just say, the planet Mars. We say the red planet, giving it a nickname, a personality. We name its mountains and valleys after scientists, writers, and words from ancient languages. Olympus Mons, the largest volcano in the solar system. Valles Marineris, a canyon system that would stretch across entire continents on Earth. These names turn geography into story. They make a distant world feel like a place with landmarks, not just coordinates. There's also something about Mars' past that feels quietly tragic, and humans are very good at being drawn to that kind of story. Once, it may have been warm and wet. It may have had rivers and lakes, maybe even a thicker atmosphere. Over time, it lost much of that. The planet cooled, its magnetic field faded, the solar wind slowly stripped away its air. What remains today is a cold, dry world, holding on to its water mostly as ice, tucked away at the poles and beneath the soil. It's hard not to see a kind of narrative in that. A world that had potential, that may have had life and then changed. We can't help but compare it, consciously or not, to our own planet and our own future. Mars becomes a kind of quiet warning, a reminder that worlds can change in ways that aren't always reversible. At the same time, it becomes a canvas for hope. If Mars once had the right conditions for life, and if humans can bring some of those conditions back, even in small, controlled habitats, then maybe it can become a place where life exists again, this time carried there by us. That idea blends science with something almost philosophical. It asks whether life has a kind of responsibility to spread, to persist, to find new corners of the universe to call home. You don't have to agree with that idea to feel its pull. It's enough to notice how often Mars shows up in conversations about the future. It appears in movies, in books, in art, and in serious policy discussions about space agencies and international cooperation. It sits at the intersection of imagination and engineering, of bedtime stories and budget spreadsheets. And in a way, that's exactly where it's always been. From ancient stargazers seeing a wandering red light, to 19th century astronomers sketching imaginary canals, to modern scientists driving robots across dusty plains, Mars has consistently lived in that space between what we know and what we wonder. It's close enough to study, but far enough to remain mysterious, real enough to measure, but distant enough to dream about. As you lie there, letting these thoughts drift by, it's worth noticing how gentle this fascination can be. You don't need to solve Mars or plan a mission in your head. You can simply let it exist as a quiet presence in the background of human thought, a reminder that the universe is bigger than our daily routines, wider than our calendars and schedules. If you were to step outside on a clear night and look up, Mars doesn't announce itself with any great fanfare. It doesn't blaze across the sky like a meteor or dominate the heavens the way the full moon does. Instead, it sits there quietly, a small reddish point among thousands of others, easy to miss if you don't know where to look, and yet that modest little glow represents one of the largest gaps between everyday human experience and the true scale of the universe. We're very good at understanding distance when it fits into our daily lives. We know how long it takes to walk to the store, to drive across town, to fly to another country. Our sense of far is shaped by hours and days, by fuel tanks and rest stops, by jet lag and time zones. Mars doesn't fit into that framework. It doesn't care about roads or airspace or the curvature of Earth. It exists in a different category of far, one that stretches our imagination as much as it stretches our engineering. To begin getting a feel for this, it helps to think about how Earth and Mars actually move. They aren't sitting still, waiting for someone to draw a straight line between them. Both planets are in constant motion, circling the Sun at different speeds on different paths. Earth completes its orbit in 1 year. Mars takes about 687 Earth days, nearly twice as long. Sometimes they're on the same side of the Sun, closer together. Sometimes the Sun sits directly between them, pushing them to opposite ends of their orbits. This dance means that the distance between Earth and Mars is always changing. At their closest, which happens roughly every 2 years during an event called opposition, they can be about 56 million kilometers apart. That's the kind of number that almost loses its meaning when you say it out loud. 56 million. It's not something you can picture easily, because there's nothing in everyday life that compares to it. If you could somehow drive a car through space at highway speed, say 100 kilometers per hour, and head straight for Mars at that closest point, the trip would take you more than 63,000 years. You'd be passing through generations of history, watching entire civilizations rise and fall, all while still being on the road. Even at the speed of a commercial jet, you'd be looking at thousands of years. These comparisons don't make the distance feel manageable. They make it feel almost mythical, like a place you could only reach in a story. But spacecraft don't travel at car or plane speeds. They move much faster, often tens of thousands of kilometers per hour. Even then, Mars is still not a quick trip. Most missions take somewhere between 6 and 9 months to get there, depending on the path chosen and the positions of the planets at launch. That path chosen part is important, because it reveals something about how space travel actually works. You can't just aim at Mars and fire the engines until you arrive. That would take an enormous amount of energy, far more than we can realistically provide. Instead, spacecraft use the gravity of the Sun to their advantage, following a curved route called a Hohmann transfer orbit. It's a kind of cosmic shortcut, where you gently fall away from Earth's orbit and gradually drift into Mars' orbit, arriving right when Mars happens to be there. This means timing is everything. There's a specific window, opening roughly every 26 months, when Earth and Mars are positioned just right for this energy-efficient path. Miss that window, and you're either waiting 2 more years, or spending a huge amount of extra fuel to take a less efficient route. In practical terms, this turns Mars into a destination that's not always available. It's not like catching a train that runs every hour. It's more like catching a rare tide that only comes in once in a while. That alone changes how you think about the journey. Once you leave Earth, you're committed, not just for months, but in some ways for years. You can't decide halfway there that you forgot something and turn around. Even if you had the fuel, the planets wouldn't be in the right places. Space travel, especially at this scale, doesn't allow for quick changes of mind. During those months of travel, the crew would exist in a kind of in-between world. Not on Earth anymore, but not on Mars yet. There's no sky to look at in the usual sense. Outside the windows, if there are windows, there's mostly black, dotted with stars that don't twinkle because there's no atmosphere to disturb the light. The Sun is just a bright, steady disk, and Earth quickly shrinks from a full, familiar world into a bright star of its own. As the days pass, that point of light becomes harder to see. Not because it's gone, but because distance is quietly doing its work. Every hour, every minute, the spacecraft is carrying its occupants farther from everything they have ever known. There's a physical distance, measured in kilometers, but there's also a psychological distance that doesn't show up on any instrument panel. Here on Earth, even in the most remote places, there's a sense that help exists somewhere. You might be far from a city, but you know one is out there. You might be in the middle of the ocean, but you know there are ships, satellites, coastlines. In deep space, that safety net thins out until it feels more like a thread. Communication with Earth makes this especially clear. On a phone call, you expect an answer right away. Even on a video call, a slight delay feels noticeable. Between Earth and Mars, the delay can be anywhere from about 3 minutes to more than 20 minutes one way. That means a simple exchange, a question and a response, can take nearly an hour. Conversations become more like letters. You send a message, wait, and then receive a reply that reflects a version of the other person from half an hour ago. This delay changes the nature of support. If something goes wrong on a spacecraft in Earth orbit, ground control can guide the crew in real time. They can talk through problems step by step. On the way to Mars, that's not possible. The crew has to handle situations on their own, at least at first. They become, by necessity, more independent, more self-reliant, not just physically, but mentally. Distance also affects something as simple as supply. On Earth, we live in a world of constant movement. Food, medicine, tools, and spare parts are always flowing from one place to another. Even remote research stations can receive shipments within days or weeks. A Mars mission doesn't have that luxury. Everything the crew will need for months, possibly years, has to be packed in advance. That includes not just food and water, but replacement parts for systems that haven't even broken yet. Engineers have to think in terms of probabilities and redundancies. What is likely to fail? What might fail? What almost certainly will fail at some point? For each of those, you need a solution that doesn't depend on a delivery truck showing up. This often means carrying extra parts, extra tools, and sometimes even machines that can make new parts, like 3D printers. The spacecraft becomes less like a vehicle and more like a tiny, self-contained world. All of this comes back to the simple fact of how far away Mars is. Distance in space isn't just about how long it takes to get somewhere. It changes what's possible, what's practical, and what's safe. There's also the way distance affects the body. On Earth, we're protected by a thick atmosphere and a magnetic field that shields us from much of the radiation streaming through space. Once you leave that protective bubble, you're exposed to a constant drizzle of high-energy particles from the Sun and from beyond our solar system. Over a 6 to 9 month journey, that exposure adds up. Radiation isn't something you can feel happening. There's no sensation, no warning. It quietly interacts with your cells, sometimes damaging DNA, sometimes passing through without much effect. Over time, though, the risk increases. It's one of the reasons Mars missions are considered so challenging. The distance means long exposure, and long exposure means higher chances of health problems, both during the mission and years later. Then there's the simple reality of living in a confined space for that long. A spacecraft bound for Mars isn't a spacious environment. It's carefully designed to be as small and efficient as possible, because every extra meter of space means more mass, and more mass means more fuel. The crew would share that limited volume day after day, month after month, with no opportunity to step outside for fresh air or a change of scenery. On Earth, if you feel restless, you can go for a walk, look out a window, change rooms, or step outside. In deep space, your world is the same set of walls, the same equipment, the same few faces. Distance turns isolation into a physical condition, not just an emotional one. Now, imagine all of this extending beyond the journey itself, into life on Mars. Once you arrive, you're not suddenly close to Earth again. In fact, in some ways, you're farther away. The same communication delays apply. The same supply challenges remain. If something breaks on Mars, there's no quick shipment from Earth. If someone gets seriously ill or injured, there's no emergency evacuation. The distance that made the journey long also makes the stay fundamentally different from anything we've experienced before. This is where the idea of a one-way trip begins to feel less dramatic and more practical. It's not that a return is impossible in theory. It's that the distance makes every step of that return complex, risky, and dependent on a long chain of things going right. To leave Mars and head back to Earth, you need to wait for another launch window, which might be more than a year away. During that time, you have to keep yourself and your systems functioning in a harsh environment. You need fuel, either brought from Earth at great cost or made on Mars using equipment that has to work perfectly. You need a spacecraft in good condition, and you need a crew healthy enough to endure another long journey through radiation and confinement. Each of these requirements is manageable on its own. Together they form a kind of layered challenge, where distance amplifies every small problem. A minor issue that would be an inconvenience on Earth can become a serious threat when you're millions of kilometers away from help. There's also a more subtle way that distance changes things, one that has to do with how we think about time. On Earth, our sense of the future is often short. We plan for tomorrow, next week, next year. Even long-term projects usually unfold over decades, not centuries. A journey to Mars, especially one that's meant to lead to long-term settlement, asks for a different kind of thinking. It stretches the timeline. It turns years into the basic unit of planning, not months. This shift affects how you see your own life. If you go to Mars knowing that a return might not be part of the plan, you start to think differently about what home means. Home becomes something you carry in memories, in messages, in small rituals you keep alive in a new place. Distance, in that sense, isn't just physical. It becomes part of your identity. Even for those of us staying on Earth, Mars's distance invites a different kind of reflection. It reminds us that our planet, for all its size and variety, is a very small, very specific place in a much larger space. The fact that another world is close enough to reach, yet far enough to feel almost unreachable, highlights how narrow the zone of our everyday experience really is. This is why Mars feels so different from, say, the Moon. The Moon is close. You can see it in detail with your eyes. Radio signals reach it in just over a second. A spacecraft can get there in a few days. It feels like part of Earth's extended neighborhood. Mars feels like another town in a different country, across an ocean that you can't see and can't cross quickly. That ocean of space is mostly empty, but it's not quiet in a scientific sense. It's filled with solar wind, cosmic rays, and tiny particles of dust moving at incredible speeds. A speck of dust in space travelling tens of thousands of kilometers per hour can be as dangerous as a bullet. Spacecraft have to be designed to withstand impacts that, on Earth, we'd never even think about. All of this is happening in an environment where there's no air to carry sound, no weather in the usual sense, no horizon to give you a feeling of scale. Distance strips away many of the cues we use to orient ourselves. Up and down lose their usual meaning in microgravity. Day and night are defined by the position of the spacecraft and the sun, not by a sky that darkens and lightens on its own. For the crew, this can create a kind of sensory distance as well. The world outside the spacecraft doesn't feel like a place you can step into. It feels like a backdrop, something observed through glass and instruments, not something you can touch or smell or hear. And yet Mars itself slowly grows larger as you approach. After months of seeing it as a bright star, it becomes a disk, then a world with visible features. This gradual change can be both comforting and unsettling. Comforting, because it means the journey is progressing. Unsettling, because it makes the reality of arrival more concrete. You're not just travelling anymore, you're leaving one world and about to enter another. Distance, in this sense, acts like a kind of mental corridor. It gives you time to adjust, to let go of one place and prepare for another. There's no sudden jump from Earth to Mars. There's a long, slow transition, measured in millions of kilometres and hundreds of days. For those who dream about Mars from Earth, that distance can feel inspiring. It represents a challenge, a frontier, a test of what we can do when we work together and aim far beyond our usual limits. For those who would actually make the journey, it represents something quieter and more personal. It's the space in which you gradually become someone who lives between worlds. These vast numbers and long timelines have a calming effect of their own. There's something about thinking in millions of kilometers and months of silent travel that can make everyday worries feel smaller, softer, less urgent. Your own room, your own bed, your own moment in time becomes a kind of gentle anchor in a universe that is, by comparison, unimaginably wide. Between Earth and Mars there is no solid barrier you can point to, no shimmering line in space, no sign that says you're leaving one world and entering another. If you were drifting there in a spacecraft looking out through a window, you would mostly see blackness scattered with distant stars and the steady, unblinking light of the sun. And yet, in that emptiness, there is something very real, something that shapes every journey, every plan, and every risk taken across that vast gap. It's an invisible wall, not made of stone or metal, but of energy, particles, and forces that don't care much about human ambition. Here on Earth, life unfolds under a kind of quiet protection. Our planet is wrapped in a thick atmosphere that softens the sun's light, slows down incoming particles, and gives us air to breathe. Around that atmosphere is a magnetic field generated deep within the planet's core that stretches far out into space. This magnetic field acts like a shield, deflecting many of the charged particles streaming toward us from the sun and from distant stars. Most days we don't notice it at all. We go about our routines, feel the warmth of sunlight, maybe watch clouds drift by, without realizing how much is being quietly filtered out before it ever reaches the ground. The moment a spacecraft leaves that protective bubble, things change. Instead of moving through a sky that cushions and moderates, it enters a region where space is not just empty, but active. The sun is constantly releasing a flow of charged particles known as the solar wind. This wind isn't like a breeze you could feel on your face. It's a stream of protons and electrons racing outward at hundreds of kilometers per second, filling the solar system with a kind of invisible weather. Sometimes it's gentle and steady. Sometimes, when the sun releases a burst of energy in the form of a solar flare or a coronal mass ejection, it becomes a storm. On Earth, these storms can create beautiful auroras, curtains of green and purple light that ripple across the sky near the poles. They can also, on rare occasions, disrupt power grids and communication systems. But for a spacecraft travelling between planets, a strong solar storm is more than a light show, it's a direct threat. High-energy particles can penetrate metal, damage electronics, and pass through human tissue, increasing the risk of radiation sickness and long-term health problems. This is one layer of the invisible wall, a kind of ever-present field of moving energy that can't be seen or felt in the usual way, but that makes its presence known through its effects. Beyond the solar wind, there is something even more persistent and hard to avoid: cosmic radiation. These are particles that come not just from our sun, but from far beyond our solar system, from exploding stars, distant galaxies, and energetic events we can barely imagine. They travel at near the speed of light, carrying enormous amounts of energy despite their tiny size. When they collide with something, whether it's a spacecraft, a piece of equipment, or a human body, they can cause damage at the atomic level. On Earth, most of these particles never reach the surface. The atmosphere and magnetic field work together to absorb or deflect them. In deep space, there is no such protection. A spacecraft can provide some shielding, but it can't block everything without becoming impossibly heavy. Every extra layer of material adds mass, and every extra kilogram of mass makes the launch more difficult and expensive. So designers are always balancing protection and practicality. They add just enough shielding to reduce the risk, but not so much that the mission becomes unfeasible. This means that for the crew, exposure is part of the journey. Not dramatic, not immediate, but steady and cumulative. Radiation in this context is like a quiet, persistent rain. You don't notice each drop, but over time you can't ignore that you're getting wet. This is another way distance changes the nature of travel. The longer you spend in this environment, the more exposure you accumulate. A short trip to the moon, lasting a few days, carries some risk, but it's limited. A journey to Mars, stretching over months, carries a much higher total dose. That dose doesn't just affect the present moment. It can influence health years later, increasing the risk of cancer, cardiovascular problems, and other conditions. But radiation isn't the only part of this invisible wall. There's also the vacuum itself. Space is not completely empty, but it's close enough that, for practical purposes, you can think of it as a place where air doesn't exist. Without a pressurized environment, the human body can't survive. The air in your lungs would rush out. Fluids in your body would begin to boil at body temperature, not because they're hot, but because there's no pressure keeping them in a liquid state. It's not a gentle or forgiving place. This means that every moment of a journey to Mars depends on the integrity of the spacecraft. Every seal, every valve, every joint in the hull matters. On Earth, if a building has a small crack or a leaky window, it's usually an inconvenience. In space, a similar flaw can become a serious emergency. The invisible wall here is the simple fact that the environment outside the ship is fundamentally incompatible with human life. Inside the spacecraft, there's a carefully maintained bubble of air, pressure, and temperature. It's a tiny, artificial Earth, floating through a place that would not hesitate to take it apart if given the chance. That contrast between the fragile, human-made interior and the vast, indifferent exterior is another aspect of what makes this journey so different from anything on our own planet. Then there's the matter of gravity, or rather, the lack of it. Between Earth and Mars, a spacecraft is in a state of continuous freefall, orbiting the Sun along with the planets. This creates an environment of microgravity, where everything floats. At first, this can feel playful, even fun. You can push off a wall and glide across the cabin. Objects hover where you leave them. But over time, the body begins to change. Muscles that don't have to work against gravity start to weaken. Bones, no longer under their usual load, begin to lose density. Fluids in the body shift upward, which can cause puffiness in the face and changes in vision. The heart doesn't have to work as hard to pump blood, so it gradually becomes less strong. These changes are manageable with exercise and careful monitoring, but they don't disappear entirely. They're another kind of invisible wall, one that doesn't block your path, but slowly reshapes you as you pass through it. Now imagine all of these factors layered together. The steady rain of radiation, the ever-present vacuum outside the hull, the long months of microgravity, the isolation and confinement. None of them are dramatic in a single moment. There's no single point where you can say, here is the wall. Instead, it's more like moving through a thick invisible fog that gradually seeps into every part of the journey. There's also the sun itself to consider, not just as a source of light and energy, but as a kind of gatekeeper between worlds. The sun's gravity dominates the solar system. It's the reason planets follow the paths they do, and it's the reason spacecraft have to follow curved routes instead of straight lines. When you travel from Earth to Mars, you're not just crossing empty space. You're moving through a complex gravitational landscape, shaped by the pull of the sun and, to a lesser extent, the other planets. This landscape doesn't feel like hills and valleys, but it behaves in a similar way. There are regions where gravity helps you along, and regions where it resists. Navigating this invisible terrain requires precise calculations and careful timing. A small error in speed or direction early in the journey can grow into a large miss by the time you reach Mars's orbit. This is why missions are planned so far in advance, and why there's so much attention to detail in every stage of launch. Once you're on your way, there's only so much you can change. The invisible wall here is made of momentum and motion, the simple fact that in space, everything you do continues, for better or worse. Even light becomes part of this barrier in a subtle way. We often think of light as instant, something that just is. Flip a switch and the room is bright. Look at the sun and you see it shining. But in space, the finite speed of light becomes more noticeable. When you look at Earth from halfway to Mars, you're not seeing Earth as it is in that moment. You're seeing Earth as it was several minutes ago. By the time you reach Mars, any image or signal from Earth is already a record of the past. This creates a kind of temporal distance layered on top of the physical one. You're not just far away in space, you're slightly out of sync in time. Every message, every picture, every bit of information arrives as a memory, not as a live connection. For the crew, this can deepen the feeling of separation. Home becomes not just distant, but delayed. The world you left behind is always a few minutes, or more, in the past. Mars itself sits on the other side of its own kind of invisible wall, one shaped by its history. Unlike Earth, Mars lost most of its magnetic field billions of years ago. Without that field, its atmosphere was far more vulnerable to the solar wind. Over time, much of its air was stripped away and carried off into space. The planet that may once have had rivers, lakes, and a thicker atmosphere became the cold, thin-skinned world we see today. This means that when you approach Mars, you're not just arriving at another planet, you're arriving at a place that has been shaped by this same invisible environment for a very long time. The forces that create the wall between Earth and Mars are the same forces that help turn Mars into what it is now. This connection gives the journey an extra layer of meaning. It's not just a matter of crossing a gap. It's a matter of entering a region where the rules of comfort and protection that we take for granted no longer apply. Now think about how all of this influences the idea of coming back. On Earth, if you go on a long trip, you can usually turn around at any point. You can decide to head home early, change your plans, or take a different route. Between Earth and Mars, that flexibility doesn't exist in the same way. The invisible wall, made of distance, radiation, gravity, and timing, makes every decision more permanent. If something goes wrong, there's no quick return path. You can't simply point the ship back toward Earth and expect to arrive in a reasonable amount of time. The planets might not be in the right positions. The fuel you have might be intended for course corrections, not a full reversal. Even if you could turn around, you'd still be facing another long journey through the same environment that already challenged you on the way out. This is why early Mars missions are often described as having a one-way character. It's not that physics forbids a return. It's that the invisible wall makes that return so demanding that it becomes a central, defining feature of the entire mission. And yet, humans are very good at finding ways to live with invisible things. We live with gravity without seeing it. We rely on radio waves, Wi-Fi signals, and magnetic fields without ever touching them. In a similar way, a crew travelling to Mars would learn to live with this invisible wall, to treat it not as a single obstacle, but as a constant companion. They would monitor radiation levels the way we check the weather. They would plan activities around solar conditions. They would exercise to keep their bodies strong in microgravity. They would maintain their spacecraft the way a sailor maintains a ship at sea, knowing that the environment outside is not forgiving. There's something quietly profound about that kind of relationship with the unseen. It requires trust, attention, and a steady kind of courage. Not the dramatic, heroic kind, but the everyday kind that shows up in routines and checklists and careful planning. For those of us listening from the comfort of Earth, it's easy to forget how much of our own safety depends on invisible systems. The air around us, the gravity beneath our feet, the magnetic field above our heads. They're always there, quietly doing their work. You might imagine that wall not as a harsh barrier, but as a kind of threshold. A region that marks the transition from one way of living to another, from a world shaped by air, water, and gravity to a world shaped by dust, cold, and thin skies. Some of the most powerful barriers in the universe aren't things you can see or touch. They're made of light, particles, time, and space itself, forming a gentle but persistent boundary between the world we know and the red planet that waits, patiently, on the other side. Long before a spacecraft ever leaves the ground, long before the countdown echoes through a control room and a column of fire lifts metal and people into the sky, the journey to Mars has already begun in a quieter place, inside the human body. Every system, every cell, every small automatic process that usually goes unnoticed on Earth is about to be asked to perform in an environment it never evolved for, over a stretch of time that's far longer than any spaceflight humanity has ever attempted. On Earth, your body lives in a kind of steady conversation with gravity. From the moment you stand up in the morning, gravity is there, gently pulling fluids downward, giving your muscles something to push against, giving your bones a reason to stay dense and strong. Your heart works against it, pumping blood upward to your brain. Your inner ear uses it to help you keep your balance. Even the simple act of breathing is shaped by it, as your lungs expand and contract in a familiar rhythm influenced by the weight of the air around you. Now imagine that conversation slowly fading. As a spacecraft leaves Earth and settles into its long arc toward Mars, the sensation of weight disappears. Not suddenly, not dramatically, but almost politely. Objects no longer fall when you let go of them. They hover. A pen stays where you leave it. A drop of water becomes a floating sphere, shimmering and fragile. The body, which has spent a lifetime responding to downward pull, now finds itself in a place where down is just a word. At first, this can feel light-hearted, even joyful. People often describe their first moments in microgravity as playful. You can push off a wall and glide across the room. You can turn a simple movement into a slow, gentle spin. But underneath that sense of novelty, deeper changes begin almost immediately. One of the first systems to notice the difference is the one that manages fluids in your body. On Earth, gravity helps keep blood and other fluids distributed in a certain way, with more of it naturally pooling in the lower parts of your body. In microgravity, that pull is gone. Fluids shift upward toward the chest and head. This is why astronauts often look a little puffy in the face while in space. Their cheeks swell slightly. Their nasal passages feel congested, as if they have a mild cold that never quite goes away. At the same time, their legs can become thinner, a phenomenon sometimes called chicken legs, because fluid isn't pooling there anymore. This shift doesn't just change how you look, it changes how your body behaves. The increased pressure in the head can affect vision. Some astronauts experience changes in the shape of their eyeballs and the way their optic nerves function, leading to blurred vision that can last even after they return to Earth. Scientists are still working to fully understand why this happens and how to prevent it, because on a mission to Mars, clear vision isn't just a comfort, it's a necessity. Meanwhile, the heart, which is used to working against gravity, suddenly finds its job a little easier. It doesn't have to pump blood upward as forcefully. Over time, like any muscle that isn't used as much, it can begin to weaken. The body, always efficient, starts to adjust to what it perceives as a new normal. Less effort seems to be required, so less capacity is maintained. Muscles follow a similar pattern. On Earth, even when you're sitting still, your muscles are working. They're keeping you upright, stabilizing your joints, maintaining posture. In microgravity, many of those small constant tasks disappear. You don't need strong leg muscles to stand. You don't need the same core strength to keep from tipping over. Without deliberate exercise, those muscles begin to shrink and weaken. This isn't something that happens overnight. It's gradual, a slow letting go of strength that the body no longer sees as necessary. On a journey that lasts months, this can become significant. That's why astronauts on long missions follow strict exercise routines, often spending 2 hours or more each day using specially designed equipment that simulates resistance. They run on treadmills with harnesses that pull them down. They lift weights that use vacuum systems or springs instead of gravity. Even with all of that effort, some loss still occurs. The goal isn't to keep the body exactly as it was on Earth. It's to keep it functional enough to handle what comes next. Bones too respond to this new environment. Your skeleton is not a static structure. It's constantly being rebuilt. Cells called osteoblasts add new bone, while cells called osteoclasts remove old bone. On Earth, the balance between these two is influenced by the stress placed on bones through walking, standing, and lifting. Gravity provides a steady signal that says, we need this strength. In microgravity, that signal weakens. The body begins to remove bone faster than it builds it. This leads to a gradual loss of bone density, similar in some ways to osteoporosis. Over a long mission, this can make bones more fragile and increase the risk of fractures, especially when returning to a gravity environment like Mars, which, while weaker than Earth's, still places a load on the skeleton. Then there's the immune system, that quiet, complex network that protects you from countless microscopic threats every day. Spaceflight seems to change how it behaves. Some parts of the immune response become less active, others become more sensitive. Latent viruses, ones that have been dormant in the body for years, can sometimes reactivate. The reasons for this aren't entirely clear, but stress, radiation, altered sleep patterns, and microgravity all seem to play a role. On Earth, if you get sick, you can usually rest, see a doctor, or go to a hospital. On a spacecraft between planets, your medical support is limited to what you brought with you and what your crew can provide. This makes even minor health issues more significant. A simple infection or injury that would be routine on Earth becomes something to monitor carefully in a place where help is far away and delayed. Sleep, something we often take for granted, also changes. On Earth, your body uses light and darkness, along with internal rhythms, to regulate when you feel awake and when you feel tired. In space, especially in orbit, you can see multiple sunrises and sunsets in a single day. On a Mars-bound spacecraft, the pattern is different but still unusual. There's no natural day-night cycle in the same way there is on Earth. The interior lighting of the spacecraft becomes the main cue for time. Crews follow carefully designed schedules, using light to help signal when it's time to be alert and when it's time to rest. Even so, many people experience disrupted sleep. They may have trouble falling asleep, staying asleep, or feeling fully rested when they wake up. Over months, this can affect mood, concentration, and overall health. Sleep isn't just about rest. It's when the brain processes memories, regulates emotions, and performs maintenance tasks that keep mental function sharp. On a mission where attention and clear thinking are critical, maintaining good sleep becomes another essential part of caring for the body. There's also the sense of taste and smell, which can shift in subtle ways. Because of the fluid changes in the head and nasal passages, food can taste different. Some astronauts report that flavors seem muted. Spicy foods become more appealing because they cut through that dullness. Meals in space are carefully planned not just for nutrition, but for enjoyment. In a confined, isolated environment, the simple pleasure of eating something that tastes good can have a surprisingly large impact on morale. Now, consider all of these changes happening at once, over a period of 6 to 9 months, before the crew even arrives at Mars. By the time they step onto the surface of the red planet, their bodies will not be the same as when they left Earth. They will be adapted, in small but meaningful ways, to a world without gravity, without natural light cycles, without the steady background of Earth's environment. And then, suddenly, gravity returns. Mars's gravity is about 38% of Earth's. It's enough to pull you down, enough to make walking feel familiar again but different. Every step would feel lighter, a little springy. At the same time, muscles and bones that have spent months in microgravity are now being asked to work against a downward pull again. This transition can be challenging. Balance can feel off. Movements that were automatic on Earth may need a bit of conscious attention at first. The inner ear, which plays a key role in sensing orientation and motion, has to readjust to a world where down is once again a consistent direction. The cardiovascular system also has to adapt. Blood, which had been more evenly distributed in microgravity, now starts pooling in the lower body again. The heart has to work harder to push it upward. Some people experience dizziness or lightheadedness when standing up, especially in the early days after returning to a gravity environment. All of this means that the first days on Mars would likely be a period of careful, deliberate movement. You wouldn't rush. You'd take your time, letting your body relearn what it means to live under a sky that pulls you toward the ground. And the journey doesn't end there. Life on Mars would continue to shape the body in its own ways. The lower gravity means that bones and muscles might never fully return to their Earth strength levels. Over years, the body could settle into a new baseline, one that's well suited to Mars, but less suited to Earth. This is one of the reasons the idea of returning becomes more complex the longer someone stays. A body adapted to Mars gravity might find Earth's full pull heavy, even overwhelming, at least at first. Rehabilitation would be possible, but it would take time and effort, and there's still much we don't know about how completely the body can recover after very long periods in reduced gravity. Then there's the role of radiation again, which doesn't stop at the journey. Mars has a very thin atmosphere and only weak remnants of a magnetic field. This means that, on the surface, radiation levels are higher than on Earth. Not as high as in deep space, but significantly more than what we're used to. Over months and years, this adds to the total exposure a person receives. To manage this, habitats might be built partially underground, or covered with thick layers of soil to provide extra shielding. Even so, radiation would remain a background presence, something to measure, monitor, and factor into daily life. The skin, the eyes, and the deeper tissues of the body all respond to this environment in ways we're still studying. It's another reminder that Mars isn't just far away in distance, it's far away in terms of how friendly it is to human biology. Beyond the physical, there's the quiet influence of long-term isolation and confinement on the body's chemistry. Stress hormones can remain elevated when a person is under constant low-level pressure, even if nothing dramatic is happening. Being far from home, limited in social contact, and aware of the risks involved in every aspect of daily life, can create a background tension that doesn't always rise to the level of anxiety, but never fully goes away either. Over time, this can affect things like immune function, sleep quality, and even how the body processes food. The mind and body are deeply connected, and changes in one often ripple into the other. This is why Mars missions are as much about psychology as they are about engineering. How people cope with long periods of separation, with small living spaces, with the knowledge that Earth is not just far away, but unreachable in any practical sense, has a direct impact on their physical health. Scientists study this by looking at people in remote environments on Earth, such as Antarctic research stations or submarines. These places share some similarities with a Mars mission: isolation, confinement, limited contact with the outside world, and a strong reliance on a small group of people. The lessons learned that help shape how crews might be supported on a journey that's even more distant and demanding. There's also the matter of aging. A Mars mission, especially one that involves staying on the planet for an extended period, would represent a significant portion of a person's adult life. Years would pass, birthdays would come and go, family members back on Earth would grow older, change, move through their own lives, while the crew experiences a very different, very contained version of time. The body, meanwhile, continues its own quiet progression. Cells divide, tissues repair themselves. The slow, natural process of aging continues, influenced by factors like radiation, stress, and environment. All of this adds another layer to the idea of a one-way journey. It's not just about whether a spacecraft can make the trip back. It's about whether the people who went can, in a deep personal sense, return to being who they were before they left. And yet, despite all of these challenges, the human body is also remarkably adaptable. It's a system that evolved to survive in a wide range of environments, from high mountains to deep oceans, from frozen tundra to hot deserts. Space and Mars represent a new kind of environment, one that's more extreme than anything we've faced before. But the same underlying ability to adjust, to find a new balance, is still there. The question isn't whether the body can change, it's how much change we're willing to accept. For some, the idea of becoming, in a small but real way, a Mars-adapted human might feel unsettling. For others, it might feel like an extension of the long story of human migration and transformation, a new chapter in how we shape ourselves to fit the worlds we choose to live on. As you lie there, breathing slowly, you might notice how steady and reliable your own body feels in this moment. The gentle rise and fall of your chest, the quiet rhythm of your heartbeat, the familiar pull of gravity holding you to the surface beneath you. These are things that feel so ordinary that they almost disappear into the background. It's enough to rest with the idea that a long journey doesn't just carry people across distance. It carries their bodies through a slow, steady process of becoming something slightly different, shaped by the space between worlds and the quiet, persistent forces that live there. When you stand up from where you are right now, You probably don't think about why your feet meet the floor instead of drifting away. You don't pause to appreciate the way your body knows which direction is down, or how every step you take is shaped by a steady, invisible pull that's been there for your entire life. Gravity is one of those quiet companions that rarely asks for attention, even though it touches almost every part of how you move, grow, and exist. The moment you leave Earth, that companion begins to fade into the background. At first, it doesn't vanish completely. A spacecraft climbing away from the planet still feels Earth's pull for a while. The engines push, the structure vibrates, and the sense of weight remains as the ship fights its way upward. But then, as the craft settles into its path around the sun, something subtle happens. The constant downward pull that has shaped every movement since birth loosens its grip. Inside the cabin, up and down lose their usual meaning. There's no floor that holds you and no ceiling that stays above you. Instead, there are just surfaces, all equally capable of becoming a wall, a floor, or a place to rest your hand. If you let go of something, it doesn't fall. It stays where it is, as if it's forgotten the rules it used to follow. This change isn't just a novelty. It's a signal that a very old relationship between your body and your environment has been interrupted. On Earth, gravity is like a constant conversation. Your muscles respond to it by staying tense enough to keep you upright. Your bones respond by maintaining their density and strength. Your heart responds by working hard enough to push blood upward against it. Even your sense of balance depends on tiny structures in your inner ear that are tuned to feel the direction and strength of that pull. In space, that conversation goes quiet. One of the first things people notice in microgravity is how effortless movement becomes. You don't walk from one end of the cabin to the other. You push off and glide. A gentle nudge can send you drifting across the room. Turning your head or waving a hand can set you slowly spinning if you're not careful. This lightness can feel freeing. There's a childlike quality to it, a sense that the usual rules have been suspended. But for the body, this freedom comes with a cost. Muscles, especially those in your legs and core, are built for a world where they have to work all the time. Even when you're standing still, they're active, making small adjustments to keep you balanced. In microgravity, many of those adjustments aren't needed. The muscles get a kind of extended break. And like any system that isn't used, they begin to change. Over days and weeks, muscle fibers start to shrink. Strength decreases, endurance fades. This isn't dramatic or sudden. It's a gradual process, easy to overlook at first. But over the course of a long journey to Mars, it can become significant enough to affect how well a person can move, lift, and respond to physical demands. This is why exercise is such a central part of life in space. It's not about fitness in the usual sense. It's about survival and functionality. Treadmills, stationary bikes, and resistance machines become as important as navigation systems and communication equipment. They're tools for reminding the body that even though gravity is absent, strength is still needed. Bones follow a similar pattern, but on a slower, deeper level. Your skeleton is constantly renewing itself. Old bone is broken down and new bone is formed. This process is influenced by stress. When you walk, run, or carry something heavy, your bones experience tiny strains. In response, they reinforce themselves, becoming denser and stronger. In microgravity, those strains are reduced. The body, always efficient, begins to shift the balance toward breaking down bone rather than building it. Over time, this leads to a loss of bone density. It's not something you can feel happening, but it shows up in measurements and scans. On a mission that lasts months, this loss can reach levels that would be considered medically concerning on Earth. It increases the risk of fractures, especially when returning to a gravity environment. Now, consider what happens when that environment isn't Earth, but Mars. Mars offers only about 1/3 of Earth's gravity. It's enough to pull you down, enough to give your steps weight, but it's not enough to fully restore the constant stress that bones and muscles are used to. This means that even after arriving, the body is still living in a kind of in-between state. The transition from microgravity to Mars gravity would be noticeable. You'd feel heavier than you did on the spacecraft, but lighter than you ever did on Earth. Walking would feel different. Jumping would send you higher and farther. Objects would fall more slowly. There would be a sense of adjustment as your brain and body recalibrate their expectations. Balance, in particular, can be tricky. Your inner ear contains structures that help you sense motion and orientation. They're filled with fluid and tiny crystals that shift in response to gravity and movement. In microgravity, these signals change. The brain learns to interpret a new set of cues. After months of that, returning to a gravity environment can be disorienting. People often experience dizziness or a feeling that the world is tilting or moving when it's not. Simple actions like standing up or turning quickly can require a moment of focus. On Mars, where the gravity is weaker and the environment is unfamiliar, this period of adjustment could be especially important to manage carefully. The heart and blood vessels also have to relearn how to work in a gravity field. In microgravity, blood is more evenly distributed throughout the body. The heart doesn't have to work as hard to push it upward. Over time, it adapts to this easier workload. When gravity returns even partially, blood starts pooling in the lower body again. The heart has to increase its effort. This can lead to a temporary drop in blood pressure when standing up, causing lightheadedness or even fainting. On Earth, this is usually a minor issue. On Mars, where medical resources are limited and the environment is unforgiving, it's something that would need careful monitoring. All of these physical changes point to a deeper idea. Gravity isn't just a force that holds you to the ground. It's a shaping influence. It's part of the environment your body evolved in, and it's woven into how your systems expect the world to behave. Leaving Earth's gravity behind means leaving behind a kind of biological home. There's also a psychological side to this change, one that's easy to overlook because it doesn't show up in scans or measurements. On Earth, gravity gives you a sense of place. There's a clear up and down, the sky's above you, the ground is beneath you. This simple orientation helps define how you move through space and how you relate to your surroundings. In microgravity, that orientation disappears. You can turn yourself upside down, sideways, or any other way, and it doesn't feel inherently wrong. Over time, this can change how you think about space and movement. Some people find it freeing, others find it unsettling. In a long confined journey where the environment is already limited, this loss of a natural frame of reference can add to a sense of dislocation. You're not just far from Earth, you're far from the physical rules that shaped your entire experience of being in a body. Now think about what this means in the context of a one-way journey. If someone goes to Mars and stays there for many years, their body may gradually settle into a new normal, one that's adapted to lower gravity. Muscles and bones might stabilize at a different level of strength and density. The cardiovascular system might find a balance that works well in that environment. If that person were to return to Earth after a very long stay, the full force of Earth's gravity could feel overwhelming. Rehabilitation would be possible, but it would take time, and the process might be more difficult the longer someone had been away. This raises a quiet, personal question. At what point does a person stop being fully Earth adapted and become something else? Something shaped by another world? It's not a dramatic transformation. There's no moment where you cross a line and suddenly become different. It's a slow shift, a series of small changes that add up over time. But the idea itself is powerful. It suggests that where you live, where you spend your days and nights, doesn't just influence your thoughts and habits. It influences your very structure. Gravity also plays a role in how we interact with the world around us. On Earth, the weight of objects tells us something about them. A heavy stone feels solid and substantial. A light piece of paper feels fragile. These sensations shape how we handle things, how we build tools, how we design spaces. On Mars, everything would feel lighter. A piece of equipment that takes 2 people to lift on Earth might be manageable by 1 person there. This changes how habitats are built, how supplies are moved, and how work is done. It can make some tasks easier, but it can also introduce new challenges. Objects are easier to move, but also easier to lose control of. A dropped tool doesn't just fall quickly to the ground. It might bounce, slide, or drift in ways that require careful attention. Even simple actions like pouring water or dusting off a surface behave differently when gravity is weaker. Liquids form thicker streams. Dust lingers in the air longer before settling. The environment feels more delicate, more sensitive to small disturbances. This can create a kind of constant awareness. You move more carefully, more deliberately, because the world doesn't respond the way you expect it to. There's also the broader planetary scale to consider. Earth's gravity is strong enough to hold onto a thick atmosphere. It keeps air, water vapor, and other gases close to the surface, creating a stable environment for weather, climate, and life. Mars, with its weaker gravity, couldn't hold onto its atmosphere as effectively, especially after it lost its magnetic field. Over billions of years, much of its air was stripped away by the solar wind. This is part of why Mars is the way it is today, cold, dry, and thin-skinned. So when humans go to Mars, they're not just entering a low-gravity environment. They're entering a world that gravity itself helped shape into something very different from Earth. The thin atmosphere, the wide temperature swings, the dry surface, all of these are connected in some way to that lower gravitational pull. Living there means living inside that history, inside a set of conditions that are quite literally lighter than what we're used to. Now consider how this ties into the idea of cost. We often talk about the cost of space travel in terms of money, technology, and resources. Those are real and significant. But there's also a cost measured in adaptation, in change, in the quiet ways a person becomes different by leaving Earth behind. Gravity is part of what makes Earth feel like home, even if we never consciously think about it. It's in the way you sink into a chair, the way your feet press into the ground, the way rain falls and rivers flow. It's in the rhythm of walking, the ease of lying down, the effort of climbing stairs. When you leave that behind, you don't just travel to another place, you step into another physical reality. For some, that might be part of the appeal, the chance to experience a world that behaves differently, to feel lighter, to move in ways that aren't possible on Earth. For others, it might feel like a subtle loss, a missing piece of something familiar and grounding. There's also the long-term view to think about. If humans establish a lasting presence on Mars, children might one day be born there. They would grow up in lower gravity. Their bodies would develop under different conditions from the very beginning. Their bones, muscles, and cardiovascular systems might be shaped in ways we can only guess at right now. For them, Mars gravity wouldn't feel like a loss. It would feel like normal. Earth, if they ever visited it, might feel heavy, overwhelming, almost oppressive. Walking could be tiring. Lifting could be difficult. The simple act of standing might require more effort than they're used to. This possibility adds another layer to the idea of a one-way journey. It's not just about individuals deciding to go and maybe not return. It's about the potential beginning of a branch of humanity that is, in a physical sense, different. That's a quiet, profound thought. It suggests that gravity, something we usually think of as a basic feature of the universe, could become a kind of dividing line between different versions of what it means to be human. And yet, for all of this, gravity is also something we carry with us in a way. Even in microgravity, the memory of Earth's pull lives in the body. The muscles remember how to work, the bones remember their shape, the brain remembers what down used to mean. That memory shows up when people return to a gravity environment and feel their weight again for the first time. Astronauts often describe that moment as powerful. The feeling of their feet pressing into the ground, the sense of being held by the planet, can be surprisingly emotional. It's not just a physical sensation, it's a reminder of where they came from. On Mars, that moment would be different, but still meaningful. The ground would pull, but gently. It would hold you, but not with the same firmness. It would feel like a quiet handshake instead of a strong grip. You might notice the simple, steady presence of gravity in your own space, the way your body is supported by the surface beneath you, the way objects stay where you put them, the way the room has a clear up and down. These are small, ordinary things, but they're part of a very specific set of conditions that make Earth what it is. Thinking about leaving that behind can make the familiar feel a little more noticeable, a little more precious. Gravity is more than a force, it's a relationship. It's something your body has been in dialogue with for your entire life. Leaving Earth means changing that dialogue, stepping into a new one with a lighter, gentler pull, and accepting the quiet, lasting ways that such a change can shape who you become. Out there between Earth and Mars, beyond the last whisper of our planet's magnetic shield, and far past the place where the moon still feels like a familiar neighbour, there is a stretch of space that doesn't announce itself in any dramatic way. There's no signpost, no sudden change in scenery, no moment where a traveller could say, "Now I've entered the deep part." Instead, it's marked by a gradual thinning of protection, and a quiet increase in things you can't see, can't hear, and can't touch in any ordinary sense, but that shape every second of the journey all the same. If you were sitting inside a spacecraft drifting along that long curved path toward Mars, the view outside might feel almost peaceful. Stars scattered across blackness, the sun a steady distant glow, and the occasional faint glimmer of a planet far away. There's no wind, no waves, no clouds rolling in. In a visual sense, it's one of the calmest places you could imagine, but calm in this case is a kind of disguise. One of the first things to understand about this space between worlds is that it's not empty in the way we usually think of emptiness. It's filled with motion, energy, and particles travelling at speeds that make even the fastest spacecraft seem slow by comparison. This is the realm of radiation, and it's one of the most persistent and unavoidable companions on a journey to Mars. Radiation in space comes from two main sources, each with its own personality, so to speak. The first is the Sun, our local star, which is constantly releasing energy in all directions. This energy takes many forms, from the warm light that reaches your face on a sunny day, to streams of charged particles that race outward into the solar system. This steady flow of particles is known as the solar wind. Most of the time it's relatively gentle, a kind of background weather in space. But the Sun is not a perfectly calm presence. It has moods. It produces flares and eruptions, massive releases of energy and matter that can send waves of high-energy particles surging through space. When one of these storms sweeps past Earth, our magnetic field and atmosphere usually take the brunt of it. We might see brighter auroras, and in rare cases some disruptions to satellites or power systems. Between Earth and Mars there's no such umbrella. A spacecraft and its crew are exposed directly. Engineers plan for this by monitoring the Sun carefully. Space weather forecasts become just as important as mission timelines. If a strong solar event is detected, the crew might move to a more shielded part of the spacecraft, a kind of storm shelter designed to reduce exposure. Even then, the protection is partial. You can't build a completely radiation-proof shell without turning your spacecraft into something too heavy to launch. The second source of radiation is more distant and in some ways more mysterious. These are cosmic rays, particles that originate far beyond our solar system. Some come from exploding stars, others from energetic events in distant galaxies. They travel through space at near the speed of light, carrying enormous energy despite being incredibly small. When one of these particles passes through a human body, it can collide with atoms in cells, breaking chemical bonds and sometimes damaging DNA. Most of the time, the body can repair this kind of damage, but over long periods, the chance of a repair going wrong increases. That's where the long-term risks come in. On Earth, you're exposed to small amounts of natural radiation every day. It comes from the ground, from the air, and from space, but it's mostly filtered and softened by the layers of protection around the planet. On a Mars mission, that exposure is significantly higher, and it continues for the entire duration of the journey and the stay. This is one of the reasons Mars travel isn't just a matter of building a fast rocket. It's a matter of managing time itself. The longer you're out there, the more radiation you accumulate. Speed becomes a kind of shield. If you can get there faster, you reduce the total dose. But going faster requires more energy, more fuel, and more complex engineering. Everything is connected. Radiation isn't dramatic in the moment. There's no sensation, no sound, no visible sign. It's a quiet presence, a kind of invisible background that never fully goes away. This makes it psychologically interesting as well as physically challenging. You can't point to it. You can't feel it. You have to trust instruments and measurements to tell you what's happening around you. This reliance on unseen data becomes part of daily life. Numbers on a screen replace sensory experience. A reading that creeps upward means it's time to take precautions, even if everything looks and feels the same as it did a moment before. In a way, this turns the spacecraft into a kind of moving observatory, not just of the outside world, but of the invisible conditions that surround it. The crew isn't just travelling through space, they're constantly measuring it, interpreting it, and adjusting their behaviour in response. Then there's the silence. We often think of space as silent, and in a literal sense it is. Sound needs a medium, like air or water, to travel. In the vacuum between planets, there's nothing for sound waves to move through. If you were somehow outside a spacecraft and something exploded nearby, you wouldn't hear it. The event would happen in complete quiet. Inside the spacecraft there is sound, of course. The hum of fans, the soft whir of machinery, the gentle clicks of instruments, and the voices of the crew. These become the entire soundscape of daily life. There's no background noise from weather, traffic, or distant cities. The world outside the walls is not just silent, it's acoustically absent. Over time, this can have a subtle effect on how people experience their environment. On Earth, sound gives us a sense of space. The echo in a room tells you how big it is. The distant rumble of thunder tells you something about what's happening beyond your immediate view. In a spacecraft, sound is contained. It doesn't travel far, it doesn't change much. This can make the interior feel even more enclosed than it already is. The auditory world is as bounded as the physical one. There's also the silence in communication. As the spacecraft moves farther from Earth, the delay in messages grows. A casual exchange turns into a series of recorded statements and responses. You speak, send, and wait. When a reply comes back, it reflects a moment in the past, not the present. This creates a kind of quiet space in conversations, not just in time, but in emotional rhythm. You can't interrupt. You can't respond immediately to a laugh or a sigh. You can't share a moment as it happens. Everything is slightly out of sync. For people used to the constant, immediate connectivity of modern life, this can feel like stepping back into an older, slower form of communication. It's closer to writing letters than making calls. That can be calming in some ways, but it can also feel lonely. Now consider how radiation and silence interact. Radiation is an invisible presence you have to monitor and manage. Silence is an absence you have to live with and fill, often with your own thoughts. Together they shape the mental landscape of the journey. There's a lot of time to think on a trip that lasts months. Time to reflect, to remember, to imagine. For some, this can be a gift. For others, it can be a challenge. The same quiet that allows for deep thought can also amplify worries and uncertainties. This is why psychological preparation is such a big part of planning long space missions. It's not just about training people to operate equipment. It's about helping them develop ways to cope with isolation, confinement, and the constant awareness of risk. People who thrive in these environments often have a certain comfort with being alone, even when they're with others. They can find ways to create small routines, small pleasures, and small moments of normalcy in an otherwise unusual setting. A favourite song played through headphones, a familiar recipe recreated from space rations, a shared joke that becomes part of the group's internal language. These things might seem trivial, but they become anchors, reminders of life beyond the walls of the spacecraft. The space between worlds is also unfriendly in a more mechanical sense. Electronics, which we rely on for almost everything in modern spacecraft, can be affected by radiation. High-energy particles can flip bits in memory, disrupt circuits, and cause temporary or permanent malfunctions. Engineers design systems with redundancy, backup upon backup, so that a single failure doesn't cascade into a larger problem. This leads to a kind of constant vigilance. Systems are checked, rechecked, and monitored. The crew becomes both passengers and caretakers, responsible for the health of the machine that keeps them alive. On Earth, machines often feel separate from us. A car breaks down and it's an inconvenience. You step out, call for help, and wait. In deep space, the machine is more like an extension of your body. If it stops working, the consequences are immediate and serious. This relationship with technology adds another layer to the experience of silence and radiation. You're not just moving through an unfriendly environment. You're relying on a carefully built island of human design to hold back that environment at every moment. There's also the simple fact of temperature. Space itself doesn't have a temperature in the way we usually think of it, because temperature is about how fast particles are moving, and in a near vacuum there aren't many particles to measure. But objects in space can experience extreme heat and cold depending on whether they're in sunlight or shadow. A spacecraft travelling to Mars will cycle through periods of exposure and shade as it rotates and changes orientation. Parts of it can become very hot when facing the sun, and very cold when turned away. Managing this thermal environment is another constant task. Insulation, radiators, and careful design help keep the interior within a narrow livable range. For the crew, this means that even something as simple as room temperature is not a given. It's another parameter being actively controlled, another reminder that the environment outside is not forgiving. All of these factors together create a kind of layered unfriendliness. None of them are dramatic on their own. There's no single villain, no single obstacle to overcome. Instead, there's a steady presence of conditions that require attention, care, and respect. This is where the idea of the invisible wall becomes more than a metaphor. It's a real set of boundaries, defined not by a line in space, but by a collection of forces and absences that shape what humans can do and how they have to live when they leave Earth behind. The wall doesn't stop you from crossing, but it makes sure that crossing is never simple. There's also something quietly humbling about this. On Earth, we're surrounded by life. Plants, animals, insects, and countless microorganisms fill the air, the soil, and the water. Even in the most remote places, there's a sense of being part of a larger living system. In the space between Earth and Mars, that system falls away. The only life in that vast region is the life you bring with you. This creates a kind of existential silence, not just an absence of sound, but an absence of biological presence. You're moving through a place where nothing else is alive, at least as far as we know. That can make the idea of life itself feel more fragile and more precious. It can also make the idea of Mars as a potential place for life feel more significant. The red planet isn't just another destination. It's one of the few places close enough to reach where life might in some form exist or have existed. The unfriendly space between worlds becomes, in this sense, a kind of moat, separating two islands of possibility. For those making the journey, this perspective can add weight to everyday actions. Eating a meal, talking with a crewmate, maintaining a system, all of it happens in a context where the surrounding universe is, for the most part, indifferent. And yet people go anyway. There's something about that choice that speaks to a particular kind of human character. Not reckless, not careless, but curious and willing to accept that some of the most meaningful experiences come with real risk and real effort. As you lie there, listening, you might notice the quiet of your own space. Maybe there's a soft hum of a fan, the distant sound of traffic, or the simple stillness of a room at night. Compared to the deep silence of space, even the smallest sound can feel rich and comforting. Thinking about radiation, silence, and the unfriendly space between worlds can make those small, familiar sensations feel a little more vivid. The air you breathe, the warmth around you, the immediacy of sound and response. These are all things that fade in different ways once you step beyond Earth's protective reach. At first glance, the idea of turning around in space feels simple. You picture a spacecraft coasting along, someone at the controls deciding they've gone far enough, and with a gentle adjustment the ship pivots and heads back the way it came. It's a comforting image, very much rooted in how travel works on Earth. Miss a turn while driving and you circle back. Feel tired on a hike and you retrace your steps. Even airplanes can turn around in mid-air if something isn't right. Between Earth and Mars, that everyday logic quietly falls apart. The moment a spacecraft leaves Earth, it becomes part of a much larger, slower, and more deliberate dance. It's no longer just moving through space. It's moving through a system of gravity, motion, and timing that doesn't offer quick reversals or easy detours. To understand why, it helps to let go of the idea of space as a road and start thinking of it more like a river. Imagine stepping into a wide, steady current. You can swim across it, you can angle yourself slightly, but you can't simply stop the flow and turn it around. The water keeps moving, and you move with it. In space, that current is made of orbital motion and momentum, shaped by the gravity of the Sun and the planets. When a spacecraft heads toward Mars, it doesn't travel in a straight line. It follows a long, curved path around the Sun, carefully calculated so that it will arrive at Mars's orbit at the same moment Mars is there. This path, often called a transfer orbit, is a kind of gravitational handshake between Earth, the spacecraft, and the Sun. At launch, the spacecraft already has Earth's orbital speed around the Sun, which is about 30 kilometers per second. That's incredibly fast, even if it doesn't feel like it. When the rocket engines fire, they don't just push the ship away from Earth. They change its speed relative to the Sun, nudging it into a slightly different orbit, one that stretches outward toward Mars' path. From that moment on, the spacecraft is, in a sense, falling around the Sun on a new trajectory. It's not being actively pushed most of the time, it's coasting, carried along by the momentum it gained at launch and the gravitational pull of the Sun. This is where the idea of turning around becomes complicated. To head back to Earth, the spacecraft would need to change its orbit around the Sun again. That means changing its speed and direction by a significant amount. In spaceflight, changes in speed are called delta V, and they're the currency of movement. Every maneuver, every adjustment, every shift in trajectory costs delta V, which comes from burning fuel. Fuel, in turn, has to be carried from Earth, and carrying fuel requires more fuel to lift it in the first place. This creates a kind of spiral. The more flexibility you want, the more fuel you need. The more fuel you need, the heavier the spacecraft becomes. The heavier the spacecraft becomes, the harder and more expensive it is to launch. For a Mars mission, planners usually carry just enough fuel for course corrections and specific planned maneuvers, not for a full reversal of the entire journey. It's a bit like setting out on a long hike with a carefully packed bag. You bring what you need to reach your destination, maybe with a little extra for safety, but not enough to wander back and forth indefinitely. Now, let's imagine a scenario. A spacecraft is halfway between Earth and Mars. Something unexpected happens. It's not catastrophic, but it makes the crew consider returning. From a human perspective, this feels like a reasonable option. Halfway there means halfway back, right? In orbital mechanics, halfway there doesn't mean what it does on a map. At that point in the journey, the spacecraft is moving on a specific path around the Sun, with a specific speed and direction. Earth is no longer where it was when the spacecraft left. It's continued moving along its own orbit. By the time the ship reaches the midpoint of its journey, Earth has travelled millions of kilometres along its path. To go back the spacecraft would need to match Earth's new position and its new speed. That requires a carefully timed and often very large change in velocity. It's not just a matter of pointing the nose toward Earth and firing the engines. If you do that without the right calculations and the right amount of fuel, you can end up in an orbit that misses Earth entirely, sending you into a long loop around the Sun instead. This is one of the most counterintuitive parts of space travel. Sometimes, to go back to a place, you actually have to go forward first. You might need to follow a longer path that intersects Earth's orbit at a later time, when Earth happens to be there again. All of this depends on timing. Earth and Mars line up in a favourable way for travel only every 26 months or so. This alignment creates what's called a launch window, a period when a transfer orbit between the two planets is relatively energy efficient. Outside of that window, the amount of fuel required increases dramatically. This applies to the return journey as well. Even if you arrive at Mars, you can't just leave whenever you want. You have to wait for the next window when Mars and Earth are positioned correctly for a relatively efficient path back. This waiting period can be more than a year, so the idea of turning around quickly becomes entangled with the slow, patient rhythms of planetary motion. The planet set the schedule, not the crew. There's also the matter of energy. To leave Earth, a spacecraft has to climb out of a deep gravitational well. That's what the dramatic rocket launch is all about. It takes enormous energy to reach orbit and even more to set off toward another planet. Mars has a weaker gravity than Earth, so leaving it is, in some ways, easier. But it's still a significant challenge. You need a functioning launch system on the surface, a spacecraft ready for the return journey, and enough fuel to get back into a path that will intersect Earth's orbit. For early missions, carrying all of that from Earth is incredibly difficult. Every kilogram of return fuel adds to the mass that has to be launched in the first place. This is why many mission designs involve producing fuel on Mars using local resources, such as extracting oxygen from the carbon dioxide-rich atmosphere and combining it with hydrogen brought from Earth or derived from water ice. In theory, this is a clever solution. In practice, it means that your return journey depends on a complex system working perfectly on another planet, for months or years, without direct human oversight. If that system fails, the option to turn around disappears. Even if everything works as planned, the return journey itself is another long passage through the same environment of radiation, isolation, and confinement. The crew would face another 6 to 9 months in microgravity, another period of exposure to cosmic rays and solar events, another stretch of delayed communication and limited medical support. This means that going back isn't just a reversal of direction. It's a commitment to repeating some of the most demanding parts of the entire mission. There's also a more subtle factor at play, one that has to do with how people adapt. After months in microgravity and time spent living on Mars, the body and mind begin to settle into a new routine, a new baseline. Muscles, bones, sleep patterns, and daily habits adjust to the environment. Mars becomes, in a practical sense, home. The longer someone stays, the more effort it takes to shift back. Returning to Earth's stronger gravity, denser atmosphere, and faster pace of life can be physically and psychologically challenging. Rehabilitation is possible, but it's not instantaneous. This adaptation process doesn't create a hard barrier, but it adds another layer of complexity to the idea of turning around. The question becomes not just, can we go back, but also, what will going back be like, and what will it cost? Now, let's look at the spacecraft itself, because it too is shaped by this one-way logic. A Mars-bound vehicle is often designed with the journey to Mars and life on Mars as its primary goals. It might not be optimized for making the same trip in reverse. Systems are arranged, supplies are stored, and spaces are organized based on the assumption of a long outbound journey followed by a long stay. The return vehicle, if there is one, might be a separate craft waiting on Mars, assembled from parts sent ahead of time. This approach reduces the mass that has to be launched from Earth. but it also means that the way back is physically and conceptually separate from the way there. This separation reinforces the feeling that the mission is not a simple round trip, but a sequence of distinct phases, each with its own challenges and dependencies. There's also the role of communication and decision-making. On Earth, when something goes wrong, teams can gather in the same room, share information instantly, and make decisions together. On a Mars mission, there's a built-in delay. By the time a message reaches Earth, the situation on the spacecraft may have already changed. This means that the crew has to be empowered to make major decisions on their own, including decisions about whether to continue, wait, or attempt to return. That level of autonomy is necessary, but it also places a heavy responsibility on the people involved. The idea of turning around becomes not just a technical maneuver, but a deeply human choice, made in a context where information is incomplete and time is stretched. Now consider how all of this looks from the perspective of someone back on Earth. It's easy to imagine a mission as a line on a screen, a little icon moving from one dot to another. It's easy to think of there and back as two equal halves of the same path. From the inside, the experience is very different. The outbound journey is full of anticipation, preparation, and the slow realization that Earth is becoming a distant point of light. The return journey, if it happens, carries its own emotional weight. It's not just about going home, it's about leaving behind a place that for a time became your entire world. This emotional dimension doesn't show up in equations, but it influences how people think about the mission as a whole. For some, the idea of a one-way journey, or at least a journey where returning is uncertain, can be a source of motivation. It frames the mission as something truly significant, something that goes beyond a visit and becomes a form of settlement. For others, it's a reason for caution. The lack of an easy exit highlights the risks and the permanence of the choice. There's also the broader context of time. A Mars mission unfolds over years. By the time a crew leaves, travels, stays, and possibly returns, the world back on Earth will have changed. Technology will advance, people will move on, events will happen. This means that even if you physically return to Earth, you're not returning to the same place you left. In a social and cultural sense, there's always a kind of one-way aspect to a journey of that length. Time itself becomes part of the barrier. Now, imagine standing on the surface of Mars, looking up at the sky. Earth is there, somewhere, a bright point among many. You know that in principle you could go back. You could wait for the window, prepare the vehicle, and make the long trip. But you also know what that entails. Another year or more of waiting, another long passage through radiation and isolation, another period of physical adaptation, another chapter of life spent between worlds. The choice to return becomes more than a technical decision. It becomes a personal one, shaped by relationships, goals, and a sense of belonging. This is where the idea of turning around really reveals its depth. It's not just about physics and fuel. It's about how deeply a journey can change the way you think about place, home, and direction. Even on Earth, long journeys have this effect. People who move to another country, who spend years in a different culture, often talk about feeling caught between two worlds. They carry pieces of both with them. Going back doesn't mean simply resuming where they left off. It means navigating a new version of the familiar. A Mars mission amplifies this experience to an extreme degree. The physical distance is vast, the time away is long, the environment is fundamentally different. So, when we say that turning around isn't as simple as it sounds, we're talking about more than a maneuver in space. We're talking about a whole network of conditions that make the journey directional in a very real sense. The planets move on their own schedules, fuel is limited, systems depend on long chains of preparation and success, bodies adapt, minds adjust, time passes. All of these things add up to a kind of momentum that's not just physical but experiential. Once you're on your way, the journey carries you forward in more ways than one. Leaving a place is often easier than returning to it, at least in the way we tend to think about things. You pack your bags, step out the door, and the world opens up in front of you. Coming home, on the other hand, usually involves retracing your steps, navigating familiar streets, and settling back into something that once felt automatic. In space, that simple rhythm is turned inside out. Getting away from Earth takes an enormous amount of energy, but coming back from another planet carries a different kind of challenge, one that isn't always obvious at first glance. When people imagine the return from Mars, they often picture the outbound journey in reverse. A rocket lifts off from the red planet, arcs through space, and eventually settles back into Earth's gravity, like a bird returning to its nest. The image is neat, satisfying, and deeply human. But behind that image lies a problem that engineers, physicists, and mission planners spend years thinking about. Energy doesn't just make the journey possible, it defines what kind of journey is even realistic. To understand this, it helps to start with something familiar. On Earth, if you want to climb a hill, you need energy. You can feel it in your legs and lungs as you walk upward. The steeper the hill, the more effort it takes. Gravity is the reason for that effort. It's pulling you back down, and every step upward is a small victory against that pull. Planets are like very large hills. Earth is a deep one. Mars is a smaller one, but it's still significant. When a spacecraft sits on the surface of a planet, it's at the bottom of that planet's gravitational well. To leave, it has to climb out, and that climb requires energy in the form of speed. This is where the idea of escape velocity comes in. Escape velocity is the minimum speed an object needs to break free from a planet's gravitational pull without further propulsion. For Earth, that speed is about 11.2 kilometers per second. For Mars, it's lower, around 5 kilometers per second, because Mars is smaller and less massive. Lower doesn't mean easy. Reaching that speed still requires a powerful rocket and a large amount of fuel. The rocket has to push not only itself and its crew, but also all the supplies, equipment, and importantly, the fuel needed for the next phase of the journey. This is where things begin to stack up. If you want to come home from Mars, you need a vehicle capable of launching from the Martian surface. That vehicle needs fuel. If you bring that fuel from Earth, you have to launch it from Earth in the first place, carry it all the way to Mars, and keep it in good condition for months or years before using it. Every kilogram of that fuel adds to the mass of the spacecraft, which means you need even more fuel to launch it from Earth. This creates a kind of loop, where the solution to one problem makes another problem bigger. Because of this, many mission designs focus on the idea of making fuel on Mars instead of bringing it all from Earth. Mars' atmosphere is mostly carbon dioxide, and there's evidence of water ice in the soil and at the poles. With the right equipment, you can, in theory, use these resources to produce oxygen and methane, a common rocket fuel. The idea is elegant. You send a fuel-making system to Mars ahead of the crew. It lands, sets itself up, and starts producing and storing fuel. Months or years later, when the crew arrives, their return vehicle is already waiting, tanked up and ready to go. In theory, this reduces the amount of mass you need to launch from Earth, and makes the whole mission more practical. In practice, it introduces a different kind of challenge. You're now depending on a complex chemical factory operating on another planet, in a harsh environment, without human maintenance for a very long time. It has to work reliably, produce enough fuel, and store it safely. If it fails, there's no easy way to fix it, and the return journey becomes much more difficult, if not impossible. This means that the energy problem of coming home isn't just about how much fuel you need, it's about where that fuel comes from, and how much trust you're willing to place in systems that are far away and out of direct control. Even if you solve the problem of launching from Mars, there's still the journey through space to consider. Once the return vehicle is on its way, it has to enter a path around the Sun that will intersect Earth's orbit at the right time. This requires precise navigation, and, again, energy in the form of speed changes. The vehicle might need to adjust its trajectory along the way, using small bursts of fuel to stay on course. All of this has to be planned carefully, because fuel is finite. There's no refueling station between Mars and Earth. Every maneuver is a trade-off. Use a little fuel now to correct your path, and you have a little less later for something else. This is why space travel is often described as a kind of accounting problem. You're constantly balancing what you have against what you need, trying to make sure the numbers work out over a journey that spans millions of kilometers and many months. There's also the energy involved in staying alive during the return. Life support systems need power, computers need power, communication systems need power. On a Mars return mission, that power usually comes from solar panels, or, in some designs, from nuclear sources. Solar panels work well near Earth, where sunlight is strong. Near Mars, the sunlight is weaker, about 43% as intense as it is at Earth's orbit. This means that solar-powered systems have to be larger or more efficient to produce the same amount of energy. During the return journey, as the spacecraft moves closer to the Sun again, power becomes more plentiful, but there are still long periods where managing energy carefully is essential. This constant attention to energy can shape daily life on board. Activities might be scheduled around power availability. Systems might be turned off or put into low power modes when not in use. The crew becomes not just travellers, but energy managers, making sure that the quiet flow of electricity keeps everything functioning. Then there's the matter of heat. Energy isn't just something you use, it's something you have to get rid of. Every electronic system, every life support process, every piece of equipment produces heat. In space, you can't cool things down by blowing air over them or letting heat rise and escape the way you can on Earth. The only way to get rid of heat is by radiating it away into space. This requires large radiators and careful thermal design. Too much heat, and systems can overheat and fail. Too little, and things can freeze. Maintaining that balance is another energy-related challenge that continues throughout the return journey. Now, step back and look at the whole picture. To come home from Mars, you need energy to launch from the surface. You need energy to shape your path around the Sun. You need energy to run your spacecraft and keep people alive. You need energy to manage heat and communication. And you need all of that to work over a long period of time without major failures. Each part of this system depends on the others. If one piece falters, it can ripple outward, affecting the whole mission. This interconnectedness is what makes the energy problem feel so large. It's not a single obstacle to overcome. It's a web of requirements that all have to be met at once. There's also a more abstract way to think about energy in this context, one that goes beyond physics and engineering. Energy, in everyday life, often shows up as effort. The effort to get out of bed, the effort to go to work, the effort to maintain relationships, projects and goals over time. A Mars mission, especially one that includes a return, is a kind of extended effort, stretched across years and millions of kilometers. The energy required isn't just in the fuel tanks and batteries, it's in the people who have to stay focused, patient, and resilient over long periods of uncertainty and routine. Waiting on Mars for a return window, for example, isn't an active process in the usual sense. There's no dramatic countdown. There's just time passing. Days, weeks, months of maintaining systems, conducting research, and living in a confined environment, all while knowing that the next major phase of the journey depends on a specific alignment of planets and a carefully prepared vehicle. That kind of waiting requires a different kind of energy, a mental and emotional one. It's about sustaining motivation and a sense of purpose in a situation where the big, visible goal is always a little way off in the future. There's also the way the return journey changes the meaning of energy for the crew. On the way to Mars, energy is about reaching a destination, about making something new happen. On the way back, energy is about preservation. It's about maintaining what you already have, protecting the people and systems on board until they can safely re-enter Earth's environment. This shift can influence how people think about their role on the mission. The outward journey is often framed as exploration. The return journey is framed as survival. Now, consider the physical act of coming back to Earth itself. After months in microgravity, the body has adapted to a world where weight is minimal. Muscles are weaker, bones are less dense. The cardiovascular system has adjusted to a different distribution of fluids. When the spacecraft approaches Earth and begins its descent, all of that changes quickly. The atmosphere, which was once a distant protective shell, becomes a thick, rushing medium. The spacecraft heats up as it pushes through the air at high speed. Parachutes deploy. Gravity grows stronger with every passing kilometre. For the crew, this is another energy-related challenge, but one that shows up as force rather than fuel. Their bodies have to absorb and respond to the physical stresses of re-entry and landing. Even if everything goes perfectly, the experience can be intense. People often need assistance walking when they first step out of a spacecraft after a long mission. Their legs may feel unsteady. Their sense of balance can be off. The simple act of standing can feel like work. This moment, when Earth's full gravity reasserts itself, is a powerful reminder of the cost of leaving it behind. The body remembers, but it also has to relearn. All of this makes the idea of a one-way journey more understandable. Not because coming home is impossible, but because coming home is, in a very real sense, another full mission layered on top of the first. You don't just go to Mars and then, if you feel like it, go back. You plan 2 major expeditions, separated by years and connected by a chain of energy requirements that has very little room for error. For early missions, this can tilt the balance in favour of staying. If you're going to invest the energy, resources and effort to get people to Mars, it may make more sense to focus on building a lasting presence there, rather than immediately turning around and repeating the entire process in reverse. This is where the energy problem becomes a philosophical one as well as a technical one. It forces a question about what the journey is really for. Is it a visit? A kind of extended field trip to another planet? Or is it a step towards something more permanent? A new place for humans to live and work and eventually call home? Energy, in this broader sense, becomes a measure of commitment. How much are we willing to invest, not just in fuel and hardware, but in time, attention, and long-term planning? As you rest with this idea, you might notice how different it feels from the way we usually think about travel. Most of our journeys are short. Even the longest flights or road trips are measured in hours or days. We rarely have to think about the deep underlying energy systems that make them possible. We just show up, get in, and go. A Mars return mission strips away that simplicity. It lays bare the layers of effort that sit beneath every movement, every change of direction, every step away from or back toward a place. There's something quietly humbling about that. It reminds us that, on a planetary scale, motion itself is precious. Every change in position, every shift in orbit, every crossing of space is paid for in energy. There's a quiet but important difference between going somewhere and living somewhere, even when the place in question is only a few hours away on Earth. Visiting a city feels light and temporary. You carry a suitcase, follow a schedule, and know there's a return date waiting on the calendar. Living in a place settles into your bones in a different way. You learn its rhythms, you find your favourite corner store, your usual walking route, the small details that turn a location into a background for everyday life rather than a destination. When it comes to Mars, that difference grows into something much larger. For a long time, most of the conversation about going to Mars has been framed around the idea of a mission, a launch, a journey, a landing, a set of goals, and then, eventually, a return. This way of thinking makes sense because it fits neatly into how we've approached space exploration so far. We send probes, we send crews to orbit, we send people to the moon and bring them back. Each trip has a clear beginning and a clear end. But Mars sits in a different category. Because of the distance, the timing and the energy involved, the idea of simply popping over for a visit doesn't quite hold together. The scale of effort required to get there is so large that once you arrive, the question naturally shifts from what will we do here to how will we live here? This shift changes everything. Let's start with something very basic. Shelter. A visitor imagines a landing craft, maybe a small habitat module, a place to rest, conduct experiments, and wait for the right time to leave. It's a temporary space, like a campsite. You expect it to be functional, safe, and comfortable enough, but you don't expect it to feel like home. Living on Mars, on the other hand, means building something that can support people not just for weeks or months, but for years. That changes the design in subtle but important ways. You don't just need walls and air, you need spaces that allow for privacy, for social interaction, for work, for rest, and for all the small, unglamorous activities that make up daily life. On Earth, a lot of what makes a place feel livable comes from things we don't consciously think about. Natural light through a window, the sound of wind or rain, the ability to step outside and feel the air on your face. On Mars, most of that is absent or heavily filtered. The sky is thin and dusty. The air outside is not breathable. The temperature can swing wildly from day to night. So, a long-term habitat has to compensate. Light becomes something you design, not something you receive. Windows, if there are any, might be small and heavily shielded. Most of the day inside is created by artificial lighting that changes in colour and intensity to mimic a natural cycle. This isn't just for comfort. It helps regulate sleep, mood, and overall health. Sound becomes something you curate as well. The environment outside is mostly silent, so the interior soundscape is defined by machinery and human activity. Over time, that can become monotonous. People might use music, recorded natural sounds, or other audio to add variety and a sense of connection to places they remember. Then there's the matter of space itself. Visiting Mars means tolerating a certain level of confinement, because you know it's temporary. Living there means making that confinement sustainable. Even in a well-designed habitat, the amount of room per person is likely to be far less than what most people are used to on Earth. There's no backyard, no long walks, no spontaneous trips across town. Movement becomes something you do within a very limited area. This makes the design of that area especially important. Small changes in layout, colour and lighting can have a big impact on how the space feels over time. A narrow corridor might feel fine for a few days. Over months it might start to feel oppressive. People who study life in confined environments, like submarines or polar research stations, pay a lot of attention to these details. They know that mental well-being is closely tied to how a space feels, not just to what it provides in a practical sense. Now think about food. A visitor might bring most of their meals with them, carefully packaged and rationed. The focus is on nutrition, shelf life, and efficiency. Eating becomes a functional activity, something you do to keep going. Living on Mars pushes this in a different direction. Over the long term, it's not realistic to ship every meal from Earth. The cost and logistics become overwhelming. This is where the idea of growing food on Mars becomes important. Not just as a technical challenge, but as a part of daily life. Growing plants in a controlled environment provides fresh food, which is valuable in a physical sense. But it also provides something less tangible, and just as important, a connection to living things. Tending to plants, watching them grow, seeing something green in a world that is otherwise red and brown, can have a powerful psychological effect. It introduces a sense of care and continuity. It turns part of the habitat into a small shared garden, a place where life is visibly unfolding. For someone visiting Mars, this might be a novelty. For someone living there, it could become a routine, a small ritual that marks the passing of time. Water is another area where the difference between visiting and living becomes clear. A short-term mission can rely mostly on water brought from Earth, supplemented by recycling systems that reclaim moisture from the air and from waste. A long-term presence needs something more robust. It needs a reliable source of water on or near Mars. This is one of the reasons scientists are so interested in the planet's water ice, both at the poles and beneath the surface in other regions. Accessing and purifying that water would be a major step toward making Mars a place where people can stay, not just arrive. But using local water also changes how people think about their relationship to the planet. It's one thing to bring everything with you, like a traveller carrying supplies into a wilderness. It's another thing to start using what's already there. That's a step towards settlement, toward a more permanent presence. Now consider work. A visit implies a set of tasks: collect samples, run experiments, test equipment, check off a list of goals, and then leave. Living implies a broader range of activities. You still do science and maintenance, but you also do things that don't have a clear, immediate purpose beyond keeping life moving forward. Cleaning, organising, repairing, planning, teaching, learning. Over time, a community begins to form, even if it's a small one. People develop roles that go beyond their original job descriptions. Someone becomes the person who's good at fixing a particular system. Someone else becomes the one who organises shared meals or keeps track of schedules. These roles create a social structure, a sense of belonging. Visiting doesn't usually allow enough time for that to fully develop. Living almost guarantees that it will. There's also the matter of time itself. A visitor's experience is defined by a countdown: days until arrival, days on the surface, days until departure. Time is a resource to be spent carefully. Living shifts that perspective. Time becomes something you inhabit rather than something you measure. You still have schedules and plans, but there's a sense of open-endedness. The future isn't a return date, it's another day on Mars. This can be both comforting and challenging. On the comforting side, it allows for a deeper sense of presence. You're not constantly thinking about leaving. You're focused on what's in front of you, on building something that lasts. On the challenging side, it removes a kind of psychological safety net. Knowing that you'll be going home can make difficult situations easier to bear. If things get stressful, you can tell yourself, this is temporary. Living somewhere means that, at least for the foreseeable future, it isn't. Now let's think about the landscape itself. For a visitor, the Martian surface is a place to explore. Every rock is interesting. Every ridge is a potential discovery. The novelty is part of the experience. For someone living there, the landscape becomes a backdrop. It's still striking, still unusual, but it's also the view you see every day. Over time, it becomes familiar. You might develop favourite spots, places that feel comfortable or meaningful, even if they're just small rises in the ground or particular rock formations near the habitat. This process of making a place familiar is deeply human. We do it everywhere we go, from childhood neighbourhoods to new cities. We attach memories to locations. We turn geography into personal history. Doing that on Mars would be a powerful thing. It would mean that, in a very real sense, the planet is no longer just a destination. It's a place with stories tied to it, stories of daily life, not just of exploration. There's also the question of identity. If you visit Mars, you remain, in a clear way, a person from Earth who went somewhere else for a while. If you live on Mars, that line begins to blur. You're still from Earth, of course. Your culture, language, and background all come from there. But your daily experience is shaped by Mars. Your routines, your challenges, your reference points are tied to a different world. Over time, this could create a new sense of us and them, not in a negative way, but in a descriptive one. People who live on Mars might start to see themselves as a distinct group, defined by shared experiences that people on Earth don't have. This is something we've seen throughout human history. Communities that settle in new environments often develop their own customs, accents, and ways of thinking, shaped by the conditions around them. Mars would be an extreme version of this process. The environment is so different, the challenges so specific, that it's hard to imagine life there not leaving a strong mark on how people see the world. There's also the role of risk. A visit carries risk, but it's bounded. You accept a certain level of danger for a defined period, and then you expect to return to a safer environment. Living on Mars means accepting that risk as a constant background presence. Systems can fail. Dust storms can damage equipment. Radiation is always there. Medical emergencies are harder to manage. This doesn't mean life on Mars would be a constant state of alarm. Humans are good at normalizing risk. People who live in earthquake zones or work in dangerous jobs often develop routines and safety cultures that make those risks feel manageable. But the difference is that, on Mars, the safety net is much thinner. There's no nearby city, No hospital down the road, no quick response team. The community is largely responsible for itself. This can create a strong sense of mutual dependence. People rely on each other not just socially, but in very practical ways. Everyone's actions matter. A mistake or a lapse in attention can have consequences for the whole group. That kind of environment can strengthen bonds, but it can also add pressure. Living there requires a certain level of trust and cooperation that goes beyond what most people experience in everyday life on Earth. Now think about communication. Visiting Mars means staying in close contact with Earth-based teams, sharing data, receiving instructions, and keeping a strong link to home. Living on Mars changes that dynamic. The time delay in communication becomes a permanent feature, not a temporary inconvenience. Conversations with Earth are always asynchronous. News arrives late. Responses go out and return much later. This can create a sense of cultural lag. Events on Earth unfold at their own pace, while life on Mars continues on a slightly different timeline. Over time, this might lead to a subtle divergence in perspective. People on Mars might start to feel that Earth is not just far away, but out of step with their daily reality. They're dealing with challenges that most people on Earth can't directly relate to, while people on Earth are living in a world that feels increasingly distant to those on Mars. This doesn't have to be a source of conflict. It can simply be a natural result of living in very different environments. But it does highlight how living somewhere new can reshape not just your physical life, but your social connections as well. There's also the question of growth and change. A visit is static. You arrive, do what you came to do, and leave. Living is dynamic. It involves change over time. People age, skills develop, relationships evolve, new people might arrive, children might be born. The idea of children on Mars is especially striking. It turns the planet from a workplace into a home. It raises questions about education, health, and what it means to grow up in a world where the sky is always a dusty pink and Earth is a star in the night. It also raises practical questions about how human development is affected by lower gravity and higher radiation. These are things we don't yet fully understand, and they would shape the long-term future of any Mars community. Now, step back and look at the emotional difference between visiting and living. Visiting is often about excitement and discovery. Living is about belonging. A visitor might feel like a guest in a strange place, always slightly outside the environment, observing it. A resident begins to feel like part of the place, even if the place itself is hostile or artificial. The habitat, the routines, the shared experiences become a kind of ecosystem, one that includes the people as much as the machines and the physical structures. This sense of belonging can be powerful. It can make difficult conditions feel more manageable because they're part of a shared story rather than a temporary hardship. At the same time, it can make the idea of leaving more complicated. If Mars becomes home, then Earth becomes something else, a place of origin rather than a place of daily life. This doesn't mean people would stop caring about Earth. Quite the opposite. Distance often deepens appreciation. Seeing Earth as a small, bright point in the sky can make its oceans, forests, and cities feel even more precious. But the relationship changes. It becomes less about being there and more about remembering, connecting, and carrying pieces of that world into a new one. All of this circles back to the idea of a one-way journey. The difference between visiting and living isn't just about logistics. It's about mindset. A visit assumes a return. Living assumes a future where the place you are becomes the center of your life, at least for a long time. For early Mars missions, this line might be blurred. People might go with the intention of staying for years, but not necessarily forever. They might hold both ideas at once, the idea of building something lasting and the idea of, one day, going back. Over time, as the infrastructure grows and the community expands, the balance could shift. Mars might become a place where people go not just to work, but to start new chapters of their lives. Thinking about living on Mars has a way of highlighting how much of what feels normal is actually tied to a very specific set of conditions, a particular planet, a particular gravity, a particular sky. It also highlights how adaptable humans can be, how willing we are to turn unfamiliar places into familiar ones, given enough time and shared experience. Somewhere along the long curve between Earth and Mars, the journey stops being mostly about distance and machines and starts becoming something quieter and more personal. The spacecraft is still moving, the systems are still humming, and the numbers on the screen still change as they always do. But inside the people making that journey, another kind of motion is unfolding. Thoughts drift, memories surface. Time begins to feel different, stretched out in a way that doesn't match the ticking of a clock. On Earth, our minds are constantly shaped by the presence of others. Even when we're alone, we're surrounded by signs of human life. Cars pass by, phones buzz, buildings, signs and voices remind us that there's a whole world of activity just beyond our immediate view. We live in a kind of background hum of connection, whether we're paying attention to it or not. Between Earth and Mars, that hum fades. Inside a spacecraft, the social world becomes very small. It's defined by the few people who share that space with you and by the delayed, filtered connection to everyone else. There's no casual interaction with strangers, no overheard conversations, no unexpected encounters. Every social moment is part of a limited, repeating circle. This kind of environment brings certain things into sharp focus. Small habits become noticeable. The way someone always taps their fingers when they're thinking. The sound of someone else's breathing in the quiet of a shared sleeping area. The way a person likes their workspace arranged. On Earth, these details are often lost in the noise of larger social settings. In a confined, isolated space, they stand out. This can lead to a kind of heightened awareness, not just of others, but of yourself. You start to notice your own routines, your own reactions, the way your mood shifts in response to the same faces and the same walls day after day. Psychologists sometimes describe this as living in a mirror. The environment reflects you back to yourself because there's so little external variety to distract from what's happening inside. For some people, this can be deeply rewarding. It creates space for reflection, for creativity, for long, uninterrupted stretches of thought. Ideas can develop slowly, without being constantly interrupted by notifications, schedules, and social obligations. The mind can wander in ways that are harder to sustain in a busy, connected world. For others, it can be challenging. Without the usual distractions, worries can feel louder. A small concern can grow as it's revisited again and again. A moment of tension with a crewmate can linger, because there's no easy way to step away and find a completely different social space. This is why the psychological side of a Mars mission is treated with such care. Selecting a crew isn't just about technical skill, it's about personality, communication style, and how people handle stress, boredom, and conflict over long periods. One of the key traits researchers look for is something called psychological flexibility. This is the ability to adapt to changing circumstances, to see situations from different perspectives, and to adjust your behaviour when things don't go as planned. In a long, isolated mission, plans almost always change, systems fail, schedules shift, unexpected challenges appear. People who can respond to these changes without becoming rigid or overly frustrated tend to cope better over time. Another important trait is a certain comfort with solitude. This doesn't mean enjoying being alone all the time. It means being able to sit with your own thoughts without feeling overwhelmed by them. It means finding ways to make use of quiet moments, rather than feeling trapped by them. Between Earth and Mars, there are many quiet moments, even daily routines, which provide structure and a sense of normalcy, can start to feel repetitive. Wake up, check systems, exercise, work, eat, communicate, sleep, repeat. On Earth, repetition is often broken up by small random events. A conversation with someone new, a change in the weather, a walk through a different part of town. On a spacecraft, the range of variation is much smaller. To cope with this, crews often create their own forms of novelty. They might celebrate small milestones, like the halfway point of the journey or a particular number of days completed. They might plan theme days for meals or entertainment. They might take turns sharing stories, music, or pieces of their own culture. These activities might seem simple, but they serve an important purpose. They create moments that stand out from the flow of routine, giving the mind something to look forward to and something to remember. Memory itself can become a kind of companion on a long journey. Photos, recordings, and messages from Earth take on a special weight. They're not just reminders of people and places, they're connections to a larger world that feels increasingly distant. Looking at a picture of a familiar street or hearing a loved one's voice can bring a rush of emotion that's different from what you might feel on Earth. It's not just nostalgia, it's a kind of temporal connection, a link to a version of life that's continuing without you. This awareness of time passing differently in two places can be both grounding and unsettling. Grounding, because it reminds you that the world you came from is still there, still alive. Unsettling, because it highlights how separate your experience has become. There's also the matter of responsibility. On a Mars mission, every person on board plays a critical role. There's no one to replace you if you're having an off day. There's no option to step out of your job and let someone else take over for a while. This can create a strong sense of purpose, which is often positive for mental health. At the same time, it can create pressure. Knowing that others depend on you and that your actions can have serious consequences can weigh on the mind. Over time, this can lead to a kind of background stress, even when everything is going smoothly. Managing this stress becomes part of daily life. Crews might use techniques like mindfulness, journaling, or regular check-ins with each other to keep things from building up. Even small habits, like having a quiet moment alone or a regular time to talk about how you're feeling, can make a difference. The mind, like the body, responds to its environment. Long-term isolation and confinement can lead to changes in mood, motivation, and even perception. Some people report that their sense of time becomes distorted. Days can blur together, making it hard to remember when something happened. Weeks can feel both long and short at the same time. Without the usual external markers like weekends, social events, or seasonal changes, the mind has to find new ways to track the passage of time. This is why many long-duration missions pay close attention to maintaining a sense of rhythm. Regular schedules, weekly rituals, and even small celebrations can help anchor the mind in a flow of time that feels meaningful rather than endless. There's also the question of identity. On Earth, we often define ourselves through a wide range of roles. We're co-workers, friends, family members, neighbours, members of communities. On a spacecraft or a small Mars habitat, many of those roles collapse into a much smaller set. You're a crewmate, you're a specialist, you're part of a tiny group that shares almost everything, from air to responsibilities. This can simplify things in some ways. There's less social complexity, fewer expectations to juggle, but it can also feel limiting. People may miss the variety of interactions and identities they had back on Earth. To address this, some mission planners encourage crew members to maintain personal projects or hobbies that are separate from their official roles. Writing, drawing, music, learning a new skill. These activities can help preserve a sense of individuality in an environment that naturally pushes toward uniformity. The physical environment itself also plays a role in shaping the mind. On Earth, we're surrounded by natural cues that help regulate our emotions and attention. Sunlight changes throughout the day, weather shifts, seasons come and go. These variations provide a kind of emotional texture to life. In a spacecraft or a Mars habitat, much of this has to be simulated. Light levels are controlled, temperature is managed. The outside view, if there is one, doesn't change much. This can create a sense of sameness that's comforting for some and draining for others. To counter this, designers often try to include elements of nature in the living space, even if they're artificial. Images of landscapes, plants, variations in lighting that mimic dawn and dusk. These touches might seem decorative, but they have a real psychological impact. They tap into deep, human responses to natural patterns, helping the mind feel more at ease in an otherwise highly engineered environment. Then there's the experience of being far away in a way that's hard to fully express. People who work in remote places on Earth, like polar researchers or submarine crews, often talk about a feeling of being out of the world. It's not just physical distance, it's a sense of being outside the usual flow of society. On a Mars mission, this feeling is amplified. You're not just far from cities or countries, you're far from your entire planet. This can create a unique perspective. Some people describe a deepened appreciation for Earth, for its diversity, its complexity, and even its problems. Seeing your home world as a small, fragile point in the sky can make its conflicts and challenges feel different, sometimes smaller, sometimes more urgent. Others describe a sense of detachment, as if they're watching Earth from the outside, like a story unfolding on a screen rather than a place they're part of. This can be both freeing and disorienting. Maintaining a healthy connection to Earth becomes an important part of psychological well-being. Regular communication, shared projects with people back home, and staying informed about what's happening in the world can help bridge that gap. At the same time, there's a balance to be struck. Being too focused on Earth can make the present environment feel like a waiting room rather than a place to live. Being too focused on the mission can make connections to home feel thin. Finding a middle ground where both worlds are held in mind is part of the emotional work of a long journey. Conflict is another area where psychology comes into play. No matter how carefully a crew is selected, disagreements will happen. Different backgrounds, different communication styles, and different ways of handling stress can lead to misunderstandings. In a confined environment, there's no easy escape from these situations. You can't go to a different building or take a long walk to cool off. The same people are there the next day and the day after that. This makes conflict resolution skills especially important. Being able to talk openly, listen actively, and address issues before they grow is crucial. Some missions include regular group discussions or check-ins specifically designed to give people a safe space to raise concerns. These practices might seem formal, but they can help maintain a sense of trust and cohesion over time. There's also the phenomenon of what psychologists sometimes call third quarter syndrome. In long-duration missions or projects, people often experience a dip in morale not at the beginning, when everything is new and challenging, or at the end when the goal is in sight, but in the middle. The novelty is worn off, but the finish line still feels far away. On a Mars mission, this middle period could last months. Recognizing this pattern and planning for it is part of the psychological preparation. Crews might schedule particularly engaging tasks or personal projects for this phase, giving themselves something to look forward to. The mind, like the body, benefits from having goals that are close enough to feel reachable. There's also the question of meaning. People often cope better with difficult conditions when they feel that what they're doing matters. On a Mars mission, that sense of meaning can come from many sources. The scientific value of the work, the idea of contributing to a larger human story of exploration, the personal significance of being part of something rare and ambitious. This sense of purpose can act as a kind of psychological shield, helping people endure discomfort, risk, and uncertainty. At the same time, purpose can shift over time. What feels inspiring at the start of a mission might feel heavy or abstract months later. Keeping that sense of meaning alive is an ongoing process, one that involves reflection, conversation, and sometimes a reframing of why the journey matters. Now, consider how all of this changes once the crew arrives on Mars. The environment outside the habitat is still hostile. The distance from Earth is still there. The communication delays remain. But there's a new element: place. Mars is not just a destination. It's a landscape, a horizon, a sky that looks different from Earth's. Being able to look out and see something that isn't just the inside of a spacecraft can have a powerful effect on the mind. Even if you can't step outside without a suit, The presence of a real physical world beyond the walls can make a difference. It can provide a sense of expansion, a feeling that your life is connected to something larger than a set of rooms and screens. Exploring the surface, even in a limited way, can break up the monotony of indoor life. It introduces new sights, new tasks, and new challenges. It can make the mission feel more tangible, more grounded in a specific place. At the same time, Mars brings its own psychological challenges. The landscape is vast, but also empty. There are no trees, no animals, no signs of other life. The sky's a different colour. The sun looks smaller. This combination of openness and emptiness can be awe-inspiring, but it can also feel isolating. It's a reminder that, in a very real sense, you are alone on a world that is not built for you. This can deepen the bond between crewmates. Shared experiences in such an environment often create strong connections. People rely on each other not just for work but for emotional support. These bonds can become one of the most meaningful parts of the entire journey. The group becomes a kind of extended family, defined not by blood or history but by a shared, extraordinary experience. It highlights how much of our inner world is shaped by the outer one, by the people, places and patterns that surround us. The greatest distance in a journey to Mars isn't always measured in kilometers or months, but in the quiet spaces between thoughts, in the slow reshaping of how a person experiences time, connection, and themselves when they live at the very edge of the world they once called home. Somewhere deep in the background of every journey, no matter how simple or how grand, there is a quiet chain of support that makes it possible. When you walk into a kitchen and pour a glass of water, you don't usually think about the pipes, the treatment plants, the reservoirs, and the people who maintain them. When you turn on a light, you don't pause to picture the power stations, the cables, and the networks that carry electricity across entire regions. These systems fade into the background of daily life, becoming so familiar that they almost disappear. On Mars, and on the long path that leads there, those systems can't disappear. They become part of everyday awareness, part of the mental landscape of everyone who lives or travels so far from Earth. The supply line between two planets isn't a set of hidden pipes and wires. It's a visible, carefully planned thread stretched across millions of kilometers of space, and it shapes what's possible in ways that are both practical and deeply human. To understand what this really means, it helps to start with something very simple. Nothing on Mars arrives by accident. Every tool, every package of food, every piece of medical equipment, every bolt, wire and fabric panel that ends up in a Mars habitat begins its journey on Earth. It's designed, built, tested, packed, launched, guided through space, and carefully landed on another world. That process can take years from start to finish. Decisions made in a design room on Earth can echo all the way across the solar system and shape daily life on Mars long after the people who made those decisions have moved on to other projects. This is a very different kind of supply line from the ones we're used to. On Earth, supply lines are flexible. If a store runs out of something, another shipment can arrive in a day or two. If a part breaks, a replacement can often be ordered and delivered quickly. There's a sense of flow, of movement, of constant availability. Between Earth and Mars, that flow slows to a careful drip. Launch windows, the periods when Earth and Mars are aligned in a way that makes travel energy efficient, open roughly every 26 months. That means that major shipments can only be sent during those times. If you miss a window, you wait more than 2 years for the next opportunity. This turns logistics into a kind of long-term strategy game. You don't just plan for what you need next week or next month. You plan for what you might need 2 or 3 years from now. You try to anticipate failures, wear and tear, changes in crew, and even changes in mission goals. Every shipment becomes a kind of time capsule, carrying not just supplies, but expectations about the future. Imagine standing in a Mars habitat and opening a container that was packed on Earth years ago. The people who packed it might have changed jobs, moved to new cities, or retired. The world back home might look very different, and yet their decisions, their choices about what to include and how to organise it, are still shaping your day. This sense of temporal distance adds a quiet layer of meaning to everyday objects. A wrench isn't just a tool. It's a message from the past, a sign that someone, somewhere, thought about a problem you might face and tried to help you solve it long before you knew you'd need it. Now think about the sheer variety of things a human community needs to function. Food, water, air, medicine, clothing, tools, spare parts, communication equipment, scientific instruments, building materials and personal items all have to be accounted for. On Earth, these needs are met by a vast interconnected network of production and transport. On Mars, that network is reduced to a small, carefully curated stream. This means that every item has to justify its place. Weight and volume become precious. A single kilogram of mass can cost thousands of dollars to launch from Earth. A small box of supplies might represent months of planning and millions of dollars of investment. This creates a constant tension between what would be nice to have and what is absolutely necessary. For the people living there, this can change how they think about things in general. Objects are no longer disposable in the same way. A broken tool isn't just an inconvenience. It's a problem that might take years to fully solve if there's no replacement on hand. This encourages a culture of repair and reuse. Items are designed to be fixed rather than thrown away. People become familiar with the inner workings of their tools, learning how to take things apart, clean them, and put them back together. Maintenance becomes a daily practice, not a background service. In this environment, knowledge itself becomes part of the supply line. Knowing how to repair a system, how to improvise a solution, how to adapt an object for a new purpose can be just as valuable as having the object in the first place. Skills and experience become a kind of invisible inventory, something the community relies on as much as any physical shipment from Earth. Now consider food again, but not just in terms of calories and nutrition. On a long-term Mars mission, food is also about variety, comfort, and morale. Eating the same meals over and over can become draining, even if they're perfectly balanced from a nutritional standpoint. Small changes in flavor and texture can have a big impact on how people feel. This is one of the reasons growing food locally becomes so important. It reduces the dependence on Earth-based shipments and adds freshness to the diet. But growing food on Mars is not simple. Plants need water, light, and nutrients. They also need protection from radiation and extreme temperatures. Growing them in a controlled environment means building and maintaining a small artificial ecosystem inside the habitat. This ecosystem becomes part of the supply line as well. Seeds might be sent from Earth, but the conditions that allow them to grow have to be created and sustained locally. The success of the harvest depends on a careful balance of technology and attention. For the people tending these plants, this can create a new kind of relationship with their supplies. Food is no longer just something that arrives in a package. It's something that grows, that responds to care, that can fail or thrive depending on daily actions. This connection can be deeply grounding in an environment that is otherwise highly artificial. It introduces a sense of continuity, a reminder of the cycles of growth and renewal that exist on Earth, even if they have to be carefully recreated under a Martian sky. Water offers another example of how supply lines shape life. A short-term mission might rely heavily on water brought from Earth and recycled as efficiently as possible. A long-term presence needs to tap into local sources. Mars has water, mostly in the form of ice in the soil and at the poles. Extracting and purifying it requires equipment, energy, and expertise. Once that system is in place, water becomes a locally managed resource rather than an imported one. This changes how people think about it. Every drop has a clear origin. Every leak is noticeable. Conservation becomes part of daily life, not just a distant environmental concern. This awareness can foster a kind of respect for resources that's easy to lose in a world where things seem to come from everywhere and nowhere at the same time. Now think about medicine. On Earth, Modern medicine relies on a vast network of manufacturing, distribution, and expertise. If a hospital needs a particular drug or piece of equipment, it can usually be obtained quickly. On Mars, medical supplies have to be planned far in advance. This means carrying a wide range of medications, tools, and diagnostic equipment, even for problems that might never occur. It also means training crew members to handle a broad set of medical situations, because there may not be a dedicated specialist for every issue. The supply line for medicine is as much about knowledge as it is about physical items. Training, procedures, and protocols become part of what's shipped, embedded in manuals, software, and the minds of the people who go. There's also the matter of redundancy. In space, redundancy is a core principle. If one system fails, there should be another that can take over. This applies to life support, power, communication, and, in many cases, supplies. You don't just bring one water filter, you bring several. You don't rely on a single communication link, you have backups. But redundancy adds mass and complexity. Every backup is another item that has to be launched, transported, and maintained. This creates a careful balancing act. Too little redundancy, and the mission becomes fragile. Too much, and it becomes too heavy and too expensive to send. Finding that balance is one of the quiet, ongoing challenges of designing a Mars supply line. There's also the question of timing. Because shipments can only arrive during certain windows, there's a natural rhythm to resupply. This rhythm can shape life on Mars in subtle ways. People might plan projects around upcoming deliveries. They might ration certain items more carefully as a shipment date approaches. The arrival of a new supply craft could become a major event, something to look forward to, not just for practical reasons, but for emotional ones as well. It represents a tangible connection to Earth, a reminder that the distant world is still paying attention, still sending help, still part of the same story. Unpacking those shipments might feel a bit like opening gifts, even when they're filled with practical, everyday items. Each box carries a sense of continuity, a link across time and space. But there's also the reality that not everything can be sent. Some things are simply too large, too heavy, or too impractical to transport across millions of kilometers. This forces a focus on using local materials whenever possible. Martian soil, for example, might be used to create building materials for habitats, shielding, or roads. This approach, often called in situ resource utilization, is about turning the planet itself into part of the supply chain. Instead of seeing Mars as just a place you visit, you start to see it as a source, a provider of certain necessities. This shift has both practical and psychological implications. Practically, it reduces the load on Earth-based supply lines and makes long-term presence more feasible. Psychologically, it changes how people relate to the planet. Mars is no longer just a backdrop. It becomes an active participant in daily life. Digging up soil to use as shielding or construction material creates a kind of physical connection to the land. Extracting water from ice ties survival directly to the local environment. These actions turn the abstract idea of another planet into something more tangible and immediate. There's also the role of technology in maintaining the supply line. Autonomous systems, robotics, and artificial intelligence are likely to play a major part in managing shipments, maintenance, and resource extraction. Robots might unload cargo, move heavy items, or operate equipment in environments that are dangerous for humans. This creates a kind of partnership between people and machines. The machines extend human capability, allowing the community to function in a place that would otherwise be overwhelming. At the same time, it introduces new dependencies. If a key robot or automated system fails, it can disrupt the flow of supplies and the balance of daily life. This makes the reliability of technology another critical part of the supply line. Now think about the emotional side of all this. Living with a supply line that stretches across millions of kilometers can create a unique kind of awareness. There's a constant, gentle reminder that you are part of a much larger system, one that includes people, places, and processes far beyond your immediate surroundings. This can be comforting, It reinforces the idea that you're not truly alone, even when you're far from Earth. There are teams back home thinking about your needs, planning shipments, and monitoring your progress. But it can also highlight vulnerability. The distance means that help, when it comes, is slow. There's no quick response, no overnight delivery. This can create a background sense of fragility, a feeling that life on Mars is always, in some way, provisional. People might respond to this in different ways. Some might find it motivating, a reason to be careful, organised, and resourceful. Others might find it stressful, a reminder of how thin the margin for error can be. Over time, a culture of preparedness is likely to develop. Checklists, inventories, and regular audits become part of daily routine. Knowing what you have, where it is, and how much remains becomes a shared responsibility. This kind of culture can foster a strong sense of community. Everyone has a role in keeping things running smoothly. Everyone's actions, even small ones, contribute to the overall health of the group. There's also a broader perspective to consider. A supply line between Earth and Mars isn't just about supporting a handful of people on another planet. It's about building a bridge between worlds. Every shipment, every communication, every shared project strengthens that connection. Over time, this bridge could become more robust. More frequent launches, more advanced technology, a growing exchange of ideas, data, and culture. In that sense, the supply line becomes a symbol of something larger than logistics. It represents a relationship between two planets, a flow of support, knowledge, and attention that ties them together. Now, imagine standing in a Mars habitat and looking at a shelf of supplies. Some items were made on Earth and travelled a long way to get there. Others were grown or built locally. Together they form a small, carefully balanced ecosystem of human life. Each object carries a story of design, of planning, of movement across space, a story of people working together across time and distance to make a life possible in a place that would otherwise be empty and silent. You might notice the objects around you in a new way. The things you use every day, the way they arrive in your life, the systems that support them. Most of the time, these systems are invisible. It highlights how interconnected modern life is, even on Earth, and how much effort goes into making things feel simple and effortless. Long before a spacecraft ever leaves the launch pad, the idea of returning is already being quietly shaped. It shows up in planning documents, in engineering diagrams, in conversations between scientists and designers who are trying to balance what is possible with what is practical. From the outside, it can look like a simple question. Will they come back, or won't they? From the inside, it becomes something much more layered, woven through with physics, logistics, human limits, and a certain kind of long-term thinking that doesn't fit neatly into a yes or no answer. Early Mars missions sit at a very particular point in that balance. They arrive at a time when our technology is powerful enough to reach another planet, but still limited enough that every additional capability comes with a heavy cost. This creates a situation where adding a guaranteed easy return option can dramatically increase the complexity, risk, and expense of the entire mission. To understand why, it helps to picture a Mars mission not as a single journey, but as a chain of journeys stacked together. The first journey is from Earth to Mars. That alone is a major undertaking, involving launch vehicles, spacecraft, life support systems, navigation, communication, and months of travel through an environment that is actively hostile to human life. The second journey is from the Martian surface back into space. That requires a launch system on another planet, fuel production or storage, and a vehicle capable of surviving both the ascent from Mars and the long trip back to Earth. The third journey is from interplanetary space back into Earth's atmosphere, which involves high-speed re-entry, heat shields, parachutes, and recovery systems. Each of these journeys is, by itself, a complex mission. Combining them into a single, seamless plan is a kind of engineering puzzle with many moving parts. For early missions, this can push the limits of what can realistically be built, tested, and funded. This is where the idea of never returning starts to take shape, not as a dramatic declaration, but as a practical trade-off. If you design a mission without a guaranteed return, you can simplify many aspects of the hardware. You don't need to carry a return vehicle all the way from Earth to Mars. You don't need to include a fully tested, fully fueled ascent system waiting on the Martian surface. You don't need to plan for the mass, volume, and complexity of a spacecraft that can survive both the outbound and inbound journeys. This doesn't mean you abandon safety. It means you shift the focus. Instead of building a system that can go there and back, you build a system that can go there and stay. You invest more in habitats, power systems, resource extraction, and long-term life support. You treat the mission as the beginning of a presence rather than a visit. This approach can make the initial step to Mars more achievable. It lowers the barrier in terms of cost and engineering to getting people there in the first place. Of course, this raises a different set of questions, ones that are less about hardware and more about people. What does it mean to send someone on a mission that doesn't include a clear path home? To explore that, it helps to look at how humans have approached long, uncertain journeys in the past. Throughout history, there have been moments when people set out not knowing if they would ever return. Early ocean explorers, settlers crossing continents, and travellers moving into remote regions often faced a similar kind of uncertainty. They carried supplies, skills, and hopes, but no guarantee of seeing their place of origin again. For many of them, the journey wasn't framed as a one-way trip in the modern sense. It was framed as a move, a relocation, a decision to build a life somewhere new. Early Mars missions, especially those designed around long-term presence, can be seen in a similar light. The difference is that the distance is far greater, the environment is far more extreme, and the connection to home is mediated entirely by technology. This changes the emotional texture of the decision. On Earth, even the most remote places are still part of the same planet. The same air, the same oceans, the same basic physical rules. On Mars, the environment itself is fundamentally different. The air outside can't be breathed. The temperature can't be tolerated without protection. The sky, the ground, and the gravity all behave in unfamiliar ways. Choosing to stay there is choosing to live inside an artificial environment for the foreseeable future, relying on machines and careful planning for every breath, every sip of water, and every meal. This is not a decision made lightly. People who volunteer for such missions often speak about a strong sense of purpose. They see themselves as part of something larger than their own lives, something that contributes to a long-term human story of exploration and expansion. This sense of meaning can be a powerful motivator, strong enough to outweigh the comfort and security of a guaranteed return. But motivation alone doesn't make a mission viable. There are also institutional and economic factors at play. Space agencies and governments operate under budgets, political cycles, and public expectations. Funding a Mars mission is already a major commitment. Funding a mission that includes a full guaranteed return system can double or triple that commitment. Early missions often have to prove that the concept works at all. They have to demonstrate that people can survive the journey, live on the surface, and maintain systems over long periods. In that context, adding the extra complexity of a return system can be seen as something to be tackled later, once the basic feasibility has been established. This creates a kind of phased approach. The first phase focuses on getting there and staying alive. The second phase, built on the lessons of the first, focuses on making the journey more sustainable and eventually more reversible. In this framework, early missions might not be explicitly labelled as one way, but they might be designed in such a way that returning is not the primary goal. The primary goal is to establish a foothold. There's also the question of infrastructure. On Earth, returning from a place is often easier because the infrastructure for coming back is already in place. Roads, ports, airports, and support systems exist on both ends of the journey. On Mars, the infrastructure for returning doesn't exist yet. To make return trips routine, you would need launch facilities, fuel production plants, maintenance facilities, and a steady flow of spare parts and upgrades. Building all of that takes time, resources, and multiple missions. Early missions are, by definition, the ones that arrive before this infrastructure exists. They're the ones that have to start building it. This means that, even if a return is theoretically possible, it might not be practical until a certain level of development has been reached on the surface. People might need to stay for years, not because they are forced to, but because the systems that would make leaving easier are still being created. There's also the reality of risk. Every major space mission involves accepting a certain level of danger. Launching rockets, travelling through radiation-filled space, landing on another planet, and living in a hostile environment all carry inherent risks. Adding a return system adds more opportunities for things to go wrong. More launches, more complex machinery, more critical moments where a failure could have serious consequences. For early missions, some planners might decide that it's better to concentrate risk in one direction, rather than spreading it across multiple phases. In other words, make the outbound journey as safe and reliable as possible, and focus on building a stable environment on Mars, rather than trying to perfect a full round-trip system from the start. This doesn't eliminate risk. It shifts where the risk is concentrated. From the perspective of someone considering going on such a mission, this shift can be framed in different ways. One way is to see it as a commitment to a new home. You're not just visiting. You're choosing to be part of building something that doesn't exist yet. You're accepting that your life will unfold in a different place, under different conditions, with a different horizon. Another way is to see it as an open-ended journey. You're going with the understanding that a return might be possible someday, but not on a fixed schedule and not as part of the initial plan. This openness can be both freeing and unsettling. Freeing, because it allows people to focus on the present, on the work and the community they're building, rather than constantly counting down to a departure date. Unsettling, because it removes a clear endpoint, a sense of closure that many of us rely on when facing difficult or demanding experiences. There's also the role of communication in shaping how this is perceived. For the people back on Earth, a mission that might never return can sound dramatic, even frightening. It can raise ethical questions about whether it's right to send people into such a situation, even if they volunteer. For the people going, the experience can feel different. They're not being sent somewhere to be abandoned. They're choosing to go somewhere to live. This difference in perspective highlights how much of our understanding of one way is shaped by where we're standing. From Earth, Mars looks distant, harsh, and empty. From Mars, Earth looks distant, beautiful, and full of life. In both cases, the otherworld is a kind of symbol, carrying emotional weight as well as physical reality. There's also the matter of legacy. Early Mars missions, especially those that establish a long-term presence, are likely to be remembered in a particular way. They won't just be seen as explorers who went somewhere and came back. They'll be seen as the first people to make another planet part of the human story. This sense of legacy can be a powerful draw. It offers a kind of continuity beyond a single lifetime, a way of being part of something that stretches into the future. For some, this is deeply appealing. For others, it can feel abstract, less tangible than the immediate connections and comforts of life on Earth. Now consider how this all ties into the idea of uncertainty. Even if early missions are designed without a guaranteed return, the future is not fixed. Technology advances, new systems are developed. What seems impossible or impractical at one point can become routine decades later. This means that a mission that begins as effectively one way might not remain that way forever. People who go to Mars in the early stages might eventually find themselves with the option to return, not because it was part of the original plan, but because the world back on Earth has changed in the meantime. This adds another layer of complexity to the decision. You're not choosing between a permanent departure and a guaranteed return. You're choosing between a known life on Earth and an unknown path on another planet, with the possibility, but not the promise, of coming back. This kind of choice is rare in modern life, where so many options are reversible and so many decisions come with clear exit strategies. It asks for a different kind of mindset, one that's comfortable with ambiguity and open-ended outcomes. There's also the social dimension to think about. If a group of people goes to Mars and stays, they begin to form a community that exists outside the direct day-to-day influence of Earth. They still communicate, they still share information and culture, but their daily experiences are shaped by a different environment and a different set of challenges. Over time, this can lead to a sense of distinct identity, not in opposition to Earth, but alongside it. A recognition that life on Mars has its own rhythms, its own priorities, its own ways of doing things. This kind of identity can reinforce the idea of staying. When a place becomes ours, the idea of leaving it can feel more complicated. Now think about the practical reality of building a return capability on Mars. It's not just about launching a rocket, it's about maintaining a whole ecosystem of technology, fuel production, vehicle maintenance, storage facilities, quality control, testing. All of this requires space, power, materials, and trained people. It also requires a steady flow of updates and improvements from Earth. In the early stages, when the community is small and resources are limited, this can be a heavy burden. It might make more sense to focus on the basics: air, water, food, shelter, and energy. In that context, return capability becomes something you plan for in the future, rather than something you build into the very first missions. This planning for the future can take many forms: landing pads for future vehicles, space reserved for fuel plants, training programs for people who will eventually take on the role of building and operating return systems. In this way, even a mission that might never return can be part of a larger story that includes eventual two-way travel. It's a step in a longer process, not the final word. As you sit with these ideas, you might notice how different they feel from the way we usually think about travel. Most of our journeys are framed around departure and return. We leave, we go somewhere, and we come back. Thinking about a journey where the return is uncertain, delayed, or not part of the initial plan invites a different perspective. It shifts the focus from movement to presence, from visiting to belonging. It also invites a certain kind of calm, not because the situation is easy or safe, but because it's clear. The path ahead is open-ended. The future is something to be built rather than something to be scheduled. When people hear the phrase one-way journey, it often brings up images of finality, of doors closing behind someone as they step into the unknown. It can sound dramatic, even a little unsettling. On Earth, most of our travels are framed by the comfort of return. We go out, we explore, and we come back to familiar ground. The idea that a journey might not include a clear path home touches something deeper than logistics. It touches how we think about ourselves, our place in the world, and what we believe is worth carrying forward. A mission to Mars that may not return invites us to look at humanity from a slightly different angle. For most of human history, the boundaries of the known world were close and visible. A mountain range, a desert, a stretch of ocean. Beyond those edges, there were blank spaces on maps and stories filled with imagination. When people crossed those edges, they didn't always know what they would find, or if they would ever see their homeland again, and yet people kept going. There's a pattern there, one that shows up again and again. Curiosity, mixed with a willingness to accept uncertainty, often pushes us to take steps that don't come with clear guarantees. A one-way journey to Mars sits within that pattern, but it also changes it in important ways. The scale is larger, the environment is harsher, the distance is so great that it reshapes what away even means. This isn't just about moving from one place on Earth to another, it's about stepping off the planet entirely. When we think about what that says about humanity, it helps to start with something very simple. We seem to have a strong relationship with the horizon. On Earth, the horizon is always there, a line where the land or sea meets the sky. It invites attention without demanding it. You can walk toward it, and it always stays just out of reach. This quiet, constant presence has shaped how we think about distance and possibility. It suggests that there is always something beyond where you are now. Going to Mars takes that idea and stretches it into a new dimension. The horizon is no longer just a line in the distance. It becomes an entirely different world, visible as a point of light in the night sky. The beyond is no longer a few days or weeks away. It's months of travel through a place that doesn't naturally support life. Choosing to step into that kind of beyond reflects a particular aspect of how humans see themselves in the universe. It suggests that we don't just want to understand the world we're in, we want to place ourselves within a larger context. We want to see how far our reach can extend, not just in terms of knowledge, but in terms of presence. A one-way journey makes that desire especially clear because it emphasizes commitment. On a round trip, you can frame the experience as temporary. You go, you learn, you return. On a one-way or open-ended journey, you're not just gathering information, you're investing part of your life in a place that might become part of who you are. This kind of investment shows up in other parts of human history as well. People who move to new countries, who build communities in remote areas, who dedicate themselves to long-term projects, often talk about a moment when something shifts from being an experiment to being a home. Mars, in this sense, becomes more than a scientific target. It becomes a potential place of belonging. That idea can feel strange at first because Mars is so different from Earth. The air is thin, the surface is dry and cold, the sky has a different colour. Everything about it seems to emphasise how far it is from being naturally welcoming, and yet humans have a long history of making themselves at home in places that don't seem welcoming at first glance. Deserts, polar regions, dense forests, high mountains. Each of these environments required new tools, new habits, and new ways of thinking. Over time, people learned how to live there, and those places became part of human geography. Mars would be an extension of that process, but on a planetary scale. Thinking about a one-way journey in this context highlights a certain confidence, or perhaps a certain hope, in our ability to adapt. It suggests a belief that, given enough time and effort, we can create a livable space even in an environment that starts out as completely hostile. At the same time, it also reveals a kind of humility. Mars doesn't bend easily to human presence. Every breath, every sip of water, every degree of warmth inside a habitat is something that has to be actively maintained. This constant dependence on technology and planning can serve as a reminder of how much we rely on the natural systems of Earth without usually thinking about them. In this way, a one-way journey to Mars can act like a mirror, reflecting back what makes our home planet special. The thick atmosphere, the flowing water, the protective magnetic field, the vast interconnected web of life. Seeing Earth from far away, as a small bright point in the sky, often leads people to describe a sense of perspective. Borders, conflicts, and everyday concerns can feel different when viewed against the backdrop of a whole planet floating in space. This perspective doesn't necessarily make problems disappear, but it can change how they're framed. It can highlight the idea that, for all our differences, we share a single, fragile home. A one-way journey brings that idea into sharper focus, because it creates a clear contrast between here and there, between the world that supports life naturally and the world that requires constant effort to make livable. There's also something to be said about the role of stories. Human cultures have always told stories about journeys. Myths, legends, and novels are full of characters who leave home, face challenges, and are changed by what they experience. Sometimes they return, sometimes they don't. In either case, the journey itself becomes a way of exploring what it means to be human. A one-way mission to Mars fits into this tradition, but with a modern twist. The challenges aren't dragons or enchanted forests. They're radiation, isolation, and the careful management of air and water. The tools aren't magic swords. They're life support systems and spacecraft, and yet the underlying themes are similar. Curiosity, courage, the search for meaning, the willingness to step into uncertainty. These themes resonate because they reflect something many people recognize in their own lives. even on a much smaller scale. Changing careers, moving to a new city, starting a family. Each of these involves a kind of one-way step, a moment where you move into a new phase of life and can't fully return to the way things were before. Mars simply amplifies that idea to a planetary level. There's also the question of who gets to go. A one-way journey isn't something most people would choose lightly. It requires a certain combination of skills, temperament, and personal circumstances. It also raises questions about representation. Whose culture, values, and perspectives will be carried to another planet? The first communities on Mars, small as they might be, would inevitably shape the tone and character of human presence there. Their habits, traditions, and ways of interacting could become the seeds of a new evolving culture. This makes the choice of early settlers especially significant. They're not just astronauts or scientists. They're, in a sense, cultural ambassadors, even if that role isn't part of their formal job description. This idea can feel both inspiring and heavy. Inspiring, because it suggests the possibility of creating something new, something that draws on the best of what humanity has to offer. Heavy, because it highlights the responsibility that comes with being first. There's also the role of cooperation to consider. A mission to Mars, especially one that involves long-term presence, is unlikely to be the project of a single person, company, or even a single nation. It requires a level of collaboration that spans borders, disciplines, and generations. Designers, engineers, scientists, policymakers, and countless support staff on Earth all contribute to making such a mission possible. The people who actually go are the visible tip of a much larger effort. This collective nature of the journey says something about how humans approach big challenges. We often talk about exploration in terms of individual heroes, but in reality it's usually a deeply social process. It's about networks of people working together, often across great distances and long periods of time. A one-way mission highlights this even more, because it emphasizes continuity. The people who start the process might not be the ones who see it through to its later stages. The project becomes something that outlives individual participants, something that belongs to a broader human story. This brings up the idea of legacy again, but in a slightly different way. Instead of focusing on individual names and achievements, a one-way journey invites us to think about collective legacy. What kind of presence do we want to create beyond Earth? What values do we want to carry with us? Do we see Mars as a place to exploit for resources, a laboratory for science, a refuge for humanity, or some combination of these? The answers to these questions are not fixed. They evolve as technology, politics, and culture change. But the act of going, especially in a way that suggests staying, forces us to engage with them. There's also an ethical dimension that often comes up in these discussions. Sending people on a mission that may not include a clear return raises questions about consent, risk, and responsibility. Even if people volunteer, even if they understand the dangers, there's still a broader social context. Families, communities, and societies are affected by the decision. At the same time, it's worth noting that many professions on Earth involve significant risk. Deep-sea fishing, firefighting, mining, and certain types of exploration all carry dangers that are well understood and, in many cases, accepted as part of the work. What makes Mars different is the combination of distance, isolation, and permanence. The risks are not just physical, they're social and emotional as well. Thinking about this can lead to a more nuanced view of what one way really means. It's not necessarily about being cut off forever. It's about stepping into a role that changes your relationship with the rest of the world in a fundamental way. There's also the perspective of time. A one-way journey can be seen as a way of extending humanity's timeline. Earth is a dynamic planet, shaped by geological processes, climate shifts, and cosmic events. Over very long periods, conditions can change in ways that affect the ability of life to thrive. Establishing a presence on another planet can be seen as a form of long-term resilience, a way of spreading the story of human life across more than one world. This is a big idea, one that reaches far beyond the scope of any single mission. Whether or not this is a primary motivation, it often sits in the background of discussions about space settlement. It adds a kind of existential layer to the practical challenges of rockets, habitats, and supply lines. At the same time, it's important not to lose sight of the present in favour of distant futures. For the people actually living on Mars, if and when that happens, life will be made up of very ordinary moments: meals, work, conversations, rest. The grand narrative of humanity's future among the stars will exist alongside the simple, daily reality of fixing a piece of equipment or tending to a small patch of plants. This contrast between the cosmic and the mundane is part of what makes the idea of a one-way journey so interesting. It combines big, abstract questions with very concrete, practical experiences. There's also a certain honesty in acknowledging that not every journey has to lead back to where it started. In many areas of life, growth involves moving forward rather than circling back. Learning something new often means leaving behind old assumptions. Building a new relationship often means changing how you relate to the world. A one-way journey to Mars can be seen as a physical expression of that idea. It's a step into a new context, with the understanding that the experience will change the people who take it, and perhaps in a small way, the people who watch from afar. Now, consider how this might feel from the perspective of someone standing on Mars, looking up at the night sky. Earth is there, visible as a bright point, a reminder of where you came from. You can't see its oceans or its cities, you can't hear its sounds, but you know they're there. That knowledge can carry a mix of emotions: connection, distance, gratitude, and maybe a sense of responsibility. You're part of a story that began long before you and will continue long after you. A one-way journey in this sense becomes less about leaving something behind and more about carrying something forward. You carry memories, knowledge, culture, and relationships into a new setting. You become a bridge between worlds, not just physically, but symbolically. This idea can be comforting. It suggests that even in the most unfamiliar place, you're not starting from nothing. You're building on a long shared human history. Idea of a one-way journey connects to your own life in small ways. The moments where you chose a path that didn't include an easy return. The times when you stepped into something new, knowing it would change you. Thinking about Mars can make those everyday experiences feel part of a larger pattern, one that stretches from personal choices to planetary scale projects. A one-way journey to another planet isn't just a technical challenge or a bold adventure. It's a reflection of a deep, enduring human tendency to look beyond the familiar, to invest in futures we might never fully see, and to find a sense of purpose in the act of stepping forward, even when the path ahead is wide, quiet, and open-ended. At some point in a long line of thinking, after the details of rockets, habitats, supply lines, and distant horizons have settled into the background, what remains is not a technical problem at all, but a simple, open space. It's a question that doesn't demand an immediate answer and doesn't come with a clear set of instructions. It just sits there, quietly, like a place to pause and breathe. How far are we willing to go? This isn't only about Mars, or about space, or even about physical distance. It's about the way humans relate to the unknown, to change, and to the idea of stepping beyond what feels comfortable and familiar. If you think back over everything that's been part of this journey, from the long months drifting between worlds to the idea of building a life under a sky that looks nothing like Earth's, there's a pattern that begins to emerge. Again and again, the story turns on a choice. Not a single dramatic moment, but a series of smaller, quieter decisions that add up over time. The decision to launch a mission at all, the decision to design systems that can last for years, the decision to send people instead of only machines, the decision, for those people, to step onto a path that may not lead back in a straightforward way. Each of these choices reflects a certain attitude toward the future. They suggest a willingness to invest effort, resources and attention in something that doesn't offer immediate rewards. They suggest a belief that what lies ahead is worth working toward, even if it's uncertain and far away. On Earth, we make similar choices all the time, though they often don't feel as dramatic. Choosing to learn a new skill means accepting a period of not being very good at it. Choosing to move to a new place means leaving behind routines and relationships that once felt stable. Choosing to care deeply about something means opening yourself up to the possibility of disappointment as well as satisfaction. In each case, there's a kind of distance involved, even if it's not measured in kilometers. There's a step away from the known and into something that hasn't fully taken shape yet. Mars, in this sense, becomes a very large and very visible version of a pattern that already exists in everyday life. It gives us a way to think about the idea of far in a broader way. Far is not just the number of months it takes to travel somewhere, it's also the amount of patience, flexibility and trust it takes to move towards something that doesn't come with a guarantee. Now, imagine for a moment the view from a Mars habitat at the end of a long day. The work is done for now. Systems have been checked, notes have been written, meals have been eaten and cleaned up. The interior lights are dimmed to a softer glow. Someone might be looking out through a small reinforced window or at a screen showing the outside view. The landscape is still. The sky has a muted, dusty colour that deepens as the light fades. The sun slips below the horizon more quickly than it does on Earth, and the temperature outside drops fast. Somewhere in that sky, Earth is there. Not as a place you can see in detail, but as a point of light, a reminder. In that moment, the question of how far we're willing to go doesn't feel like a philosophical debate or a topic for a meeting. It feels personal. It might show up as a memory of a familiar street, a voice, a smell, a piece of music. It might show up as a quiet sense of pride, of being part of something rare and difficult. It might show up as a mix of both. Because humans are very good at holding more than one feeling at the same time. That ability to hold mixed feelings is, in a way, part of what makes these journeys possible. You can be excited and afraid. You can be hopeful and uncertain. You can feel connected and far away at the same time. These are not contradictions to be resolved. They're part of the experience. When we talk about going far, whether to another planet or into a new phase of life, we're often talking about this emotional complexity as much as the physical act of moving. There's also a sense in which the question isn't only about the people who go. For every person who might one day stand on Mars, there are countless others who support the effort from Earth, engineers who design systems, scientists who analyze data, teachers who explain why any of this matters, families and friends who live with the idea that someone they care about is far away in a very literal and very real sense. Their version of how far are we willing to go looks different, but it's still there. It might be the willingness to let someone you love pursue something difficult and uncertain. It might be the patience to wait for messages that take many minutes to arrive. It might be the choice to care about a project whose results you may never personally see. This broadens the idea of the journey. It's not just a line from Earth to Mars, it's a web of connections that stretches across people, places, and time. Now consider how this question plays out on a larger scale. As a species, we've always balanced two tendencies. One is the desire to stay close to what's familiar and safe. The other is the desire to see what's over the next ridge, across the ocean, or beyond the sky. Neither of these tendencies is right or wrong. They exist in tension with each other, and that tension shapes much of human history. Periods of exploration and expansion are often followed by periods of consolidation and reflection. New technologies open up new possibilities, and societies have to decide how or whether to use them. Mars sits in the middle of this kind of moment. The technology to reach it is emerging. The ideas about what it might mean to live there are still forming. The decision about how far to go in a collective sense is not settled. Different people and cultures will answer the question in different ways. Some will see Mars primarily as a place for science, a laboratory for understanding planets, climate, and the potential for life beyond Earth. Others will see it as a stepping stone, part of a longer path toward a more widespread human presence in space. Still others will look at the challenges and ask whether the energy and resources might be better spent closer to home. These perspectives don't have to cancel each other out. They can coexist, shaping a conversation that evolves over time. What's interesting is that, regardless of where you land in that conversation, the very fact that it exists tells you something about humanity. It tells you that we're not only concerned with what's directly in front of us, we're also concerned with what lies beyond our immediate reach, both in space and in time. This long view is not something every species, or even every culture, necessarily develops. It's something that has grown alongside our ability to communicate, to record history, and to imagine futures that extend beyond our own lifespans. A journey to Mars, especially one that may not include a clear return, sits squarely in that long view. It's a project that unfolds over decades, involving people who will never meet each other, connected by a shared goal that outlasts individual careers and in some cases individual lives. There's something quietly powerful about that. It suggests that part of what drives us is not just personal achievement, but participation in something that feels larger than ourselves. Now bring this back down to a more immediate human scale. Think about the room you're in right now, the way the light falls, the sounds or the quiet, the way your body feels as you rest or sit or lie there. All of this is happening on a planet that, for most of human history, was the entire universe, as far as people were concerned. The sky was a ceiling, not a doorway. Today, we know that the sky's not a boundary, it's an opening. That knowledge doesn't force us to go anywhere. It simply changes the context in which we live. It means that, even as we go about our ordinary days, there's a wider stage in the background. A sense that our world is part of a much larger system of stars, planets, and empty spaces. The question of how far we're willing to go lives in that space between the ordinary and the vast. It can show up in small ways, like the decision to take a chance on something new in your own life. It can show up in big ways, like the collective choice to send people to another planet. In both cases, it involves a mix of curiosity and care. Curiosity about what might be possible, care for what already exists. There's also a rhythm to this kind of thinking that's worth noticing. We tend to swing between looking outward and looking inward, between imagining distant futures and attending to present moments, between asking big questions and taking care of small, practical needs. A Mars mission, especially one framed as open-ended, reflects this rhythm. On one level, it's about long-term goals, human destiny, and the future of life beyond Earth. On another level, it's about very immediate concerns, like whether the air system is working, whether the water supply is clean, and whether the plants in the small growing area are getting enough light. Both levels matter. Neither can be ignored. This balance can serve as a gentle reminder for life on Earth as well. Big dreams and everyday routines are not opposites. They're parts of the same picture. Now, imagine the question being asked not just by individuals or by a single generation, but by humanity over time. Each generation inherits a set of tools, ideas, and challenges. It adds something to that set and passes it on. The people who first looked seriously at Mars as a place for humans are building on centuries of astronomy, physics, engineering, and exploration. The people who might one day live there will build on what those early planners and explorers create. In this sense, how far are we willing to go is not a question that gets answered once and then set aside. It's a question that gets revisited, reshaped, and reinterpreted as circumstances change. What feels far today might feel closer tomorrow. What feels impossible now might become routine in the future. At the same time, there will always be new horizons, new distances, new unknowns. This ongoing nature of the question can be strangely comforting. It suggests that curiosity and exploration are not phases that we move through and then leave behind. They're ongoing aspects of being human. Now consider how this might feel to someone who never goes to Mars, who never works on a spacecraft or studies planetary science, but who still lives in a world where these possibilities exist. You might encounter the idea in a book, a video, a conversation, or a quiet moment of looking up at the night sky. You might feel a flicker of interest, or wonder, or skepticism, or indifference. All of those reactions are part of the same larger picture. They reflect the fact that these questions touch on values, priorities, and ways of seeing the world that are deeply personal. For some, the idea of going far, of reaching beyond Earth, feels inspiring. For others, the idea of focusing more attention on the planet we already have feels more meaningful. These perspectives don't have to be in conflict. They can inform each other. Caring about Earth and imagining life beyond it can be part of the same impulse. A desire to understand, protect, and appreciate the place we inhabit, while also recognizing that it exists within a much larger universe. There's also a quiet, practical side to all of this. Even if no one ever takes a truly one-way trip to Mars, the process of trying to make it possible leads to advances that ripple back to Earth. Improvements in renewable energy, recycling systems, water purification, medical monitoring, and materials science often come from the demands of space exploration. In this way, asking how far we're willing to go can also be a way of asking how much we're willing to learn and develop along the way. Now let the question settle again, not as something to solve, but as something to sit with. How far are we willing to go? It can be asked on a planetary scale, about rockets and red worlds and distant futures. It can be asked on a personal scale, about choices, changes, and the shape of a single life. In both cases, the answer doesn't have to be a sentence or a plan. It can be a direction, a feeling, a willingness to stay curious. As you rest here, listening, breathing, and letting these ideas drift through your thoughts, you might notice that you don't actually have to decide anything right now. The question can remain open, like a window rather than a door. Outside that window, there's a night sky, whether you can see it or not. There are stars, planets, and wide stretches of space, where human-made objects are slowly, steadily moving along paths shaped by gravity and time. Inside, there's this moment, the place you are, the sound of your own breath, the simple fact of being here on this planet at this time. The two perspectives don't cancel each other out. They sit side by side, the vast and the immediate, the distant and the close. And in that quiet space between them, the question of how far we're willing to go can remain what it is. Not a challenge to be answered, but an invitation to keep looking, keep wondering, and keep finding meaning in both the journeys we imagine and the moments we're living right now. As the story of exploration, in all its forms, continues to unfold,